for your availability and help to select the best group for Mas Alamsyah Kotohanza as Head of Data Science Indonesia, and also Mas Akbar from Jabar Digital Service representative, and also Mas Endian as CEO from ICRA, and also Miss Alvina from Government Technology from Singapore. Thank you so much for your help. I would like to maybe we can collaborate more in another session. And also, I would like to say thanks to all teams who participate. Currently, last update from tonight, there are 265 teams has been participate, but unfortunately, we have to select only certain selected teams. So, congrats to all teams has been selected. You guys are awesome, but I think this is the beginning. This is the beginning. I hope you guys can inspire more to another data enthusiasts, especially in Indonesia. So you have to show your capability, your enthusiasm, and also not only how to showcasing the modeling, but also how to give benefit to the others. I mean, give impact to the community. And I think they will be started now, the competition. So good luck to the selected teams. I hope you can show the best of you guys and you can inspire the others. Thank you.
Thank you, Mr. Nabil, for the opening speech. On today, we have the best 13 teams as the finalists of Danton competition who has come through from our data challenge. There are Das Gulu, Data Science Everyday, X Pegasus, AM Hatim, Murid Pasigit, Lulus 2021, To the Moon, Stongs, Bandarmologi, Tugas Met Statmana, Belum Discuss, Doa Orang Tua, and Papa Hanif. Before we are going to the presentation session, I will announce the judges first and then the rules for the main presentation. For the judges, we have 4 amazing people such as Mr. Alamsyah Kotohanza as Head of Data Science Indonesia Community. Say hello to Mr. Alamsyah, everyone. And next, we also have Mr. Akbar Maulana as Data Science from Jabar Digital Service. We also have Mr. Endian Rahmanda as Chief Operating Officer of ICRA. And last but not least, we have Ms. Alvina Go as Deputy Director of Artificial Intelligence Platform of the SAID GovTech Singapore. Hello, judges.
Hi.
Hello.
Hi. Nice to meet you all.
Hello.
Okay. Thank you so much to those amazing judges for coming today. Hopefully, we can find the best group that can be the winner of Data National Hackathon. And then, for the rules of the presentation, we have 2 important points. There are, in number 1, presentation will take 10 minutes maximum for each team. The presentation time will start after the host invited the team to start presenting the presentation material. And number 2, Q&A session will take 9 minutes for all judges. The Q&A session time will start after the host invited the judges to ask the participant. Thank you. Hello data people, welcome back to Data National Hackathon. Now, we are going to our main event presentation from each teams. In this first session, there will be 6 teams who will present their ideas first, and after the break, there will be another 7 teams who will present their ideas. The first team who will be the presentation is Dasgulu. Hello team Dasgulu.
Hi.
Hi. Okay, thank you. There are 3 amazing participants in this team, including Ilham Dwi Prastio, Francisca Diva Amadea, and Muhammad Nanda Setiawan. Dasgulu, please present your ideas. Good luck.
Excuse me. Can I share our PowerPoint presentation?
Yes, you may.
Uh, Sorry, but I'm still cannot share. Host, please.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Data Science Weekend, for the opportunity. And we're from the school team, and we would like to present our project for Data National Hackathon 2021. But first, let us introduce ourselves. We are from the school team, and the leader of this team is Hamdi Prastyo, and the members are me, Francisca Diva Amadia, and Muhammad Nanda Setiawan. Next, let's start from the background first. Okay, for the problem, we will tell you a story about the demographic of Jawa Barat or West Java. And statistic of Jawa Barat stated that from the result of the Census Penduduk 2020, that the population of West Java in September 2020 was 48.27 million people. Compared to the results of the previous census, the population of West Java continues to increase. In 10 years since 2010, the population has increased by around 5.2 million, or an average of 0.44 million every year. During that time period, the population growth rate of West Java was 1.11% per year. And talking about the density, with an area of 35.38 thousand square kilometers, the population density of West Java is 1.365 people per square kilometer. This number has increased from the SP 2000 results, which the population of West Java was as much as 1,010 people per square kilometer, and the SP 2010 results reached 1,207 people per square kilometer. And then the total number of vehicles in West Java in 2018 was recorded at 35.9 million. One of the cities that is in the spotlight and has serious problems is Bandung. Verified by the Asian Development Bank in October 2018 stated that Bandung was the 14th most congested city in Asia, above Jakarta, which was ranked 17th. This is very reasonable because the growth of vehicles in the city of Bandung has increased by an average of 11% each year. It resulted in congestion on several roads in the city of Bandung. And according to data from Bandung City Transportation Service, there were 1,251,082 wheeled vehicles in Bandung, while four-wheel total 506. And next, knowing this problem, Data Science Weekend collaborates with Jabar Digital Service or JDS to see and investigate further problems by inviting all data enthusiasts in Indonesia to participate in building a machine learning-based model to predict which sector will get high returns at certain hours. The prediction results will be used and directed as input and consideration for GDS for and local governments in West Java to make policies related to this specific problem. The competition used race data information from GDS from September 2020 to November 2020, and the data covers three disease areas in West Java, Bandung, Bogor, and Bekasi. Information for the last week of November will be saved as test data, while other data will be used for training. SI and GDS invited the team to develop a model that can predict a high reports for reducing pneumonia in certain areas, dates, and times around the last week of November 2020. Next, okay, we will look at the visualization of the training data. Okay, the first graph shows the time and number of traffic jams. Okay, from the graph, we can see that the 17 o'clock or 5 p.m. is the time that has the most numbers of traffic jam, followed by 18 o'clock or 6 p.m. And then on the second graph, on the right one, shows the dates and numbers of traffic jams. We can see that the highest traffic jams happened at around 30 October 2020. Okay, and the next graph. Um, the table shows the information on days and traffic jam percentage. Okay, we can see from the table that the Saturday has the highest traffic jams percentage, followed by Friday, Thursday, Sunday, Tuesday, Monday, and Wednesday. Okay, next. Okay, this is the top 10 ID in training dataset. ID represent S2 ID or token. It is a unique ID that represents a rectangular area in map. And we can see that from the top 10 ID, Depok has the most occurrence in traffic jam. Okay, and the first ID that has the most frequencies of traffic jam is shows on the right side. That is the location. Next. And then this is the information for data frame that has two attributes, that is IDs and labels. IDs is a string consists of ST token, dates, and hours. Labels has two values, true indicating traffic jam and false indicating peak flow. Next.
Okay, and then the initial training data consists of ITS and labels. We want to split the IT test and hours from ITS data, so we need to create new columns. So after splitting the ITS, we have four columns as displayed on the right table. Next. Okay, we need to pre-process the data. We assume that IT tests and hours are categorical data. So we create a dummy variable. The number of columns become around 4600 because the number of columns in the training data and the test data is different. We drop the column that don't exist in the test data. Next. After that, we scale the data by applying the incremental principal component analysis or IPCA so that the data will be statistical distributed and reduce outlier. Next.
Okay. After the data is ready, we use the train data with SVM model. We choose SVM model because it is a robust model and it will find a hyperplane that optimize the distance between the classes, and the parameter for our model is use C equal to 1, then gamma equal to scale, and kernel that we use is RBF. Okay. After we implement the model, we get the model and we use to test data. And the result from the test data shown in this graphic, we can see that the most congested area is from Bekasi and then followed by Bandung. And then in the other side, the most uncongested area is like in Gunung Sindur, in Parongpong, and Cilengsi, Cimahi. And conventional crimes such as death accompanied by violence, death accompanied by victim, and death of motorcycle still dominate crime in West Java throughout 2020. The results of the prediction that regions experiencing the least congestion or the least amount of mobilization can be used as a reference for the patrol routes of the police in West Java, such as in Cibinong and Cimahi. Okay, I think that's all about our presentation. Send back to the moderator. Thank you.
Okay, thank you so much, Tundas Gulu, for those presentation. Now, it's time for Q&A session. For the judges, is there any question that you want to ask to this team?
Maybe from me. Check.
Yes, Mas Akbar. Yeah.
All right. Thank you for Ndaskulu team. Based on your presentation, I think the characteristic about traffic behavior in each city is different. Based on your analysis or your modeling, please give me a recommendation for each city. Okay.
Recommendation. Oh,
Can we ask for a minute for discussing or should we answer it directly?
Okay.
The processing and you tell us about the modeling part, what model that you use. But can you tell us about how do you choose, how do you do the evaluation? What do you find on that when you do the evaluation? What do you find it, and what is the best feature maybe that you use for this modeling? Thank you.
Okay, let me answer for the evaluation. We use metric equation.
accuracy.
We split the train data into train data and validation data. Then we test the model on the validation data and we use the metric accuracy.
Use what? Sorry, can you repeat it again?
Accuracy. Accuracy.
Oh, okay. And then what is the best feature? Give me just top three, maybe.
Okay, the best feature is ID, SQ ID, and then hours, and dates.
Okay. Okay, got it. Thank you.
Okay. Question from me. First of all, thank you. That's good team. Very good presentation. I do have a question that you mentioned before that you dropped the IDs that are not exist in the testing data, right? So does that mean that you train the data using not using all the IDs that represents Jawa Barat, which means that is it possible for your model to predict traffic where there has been no traffic before?
Okay. Okay. Because we are using only the data from the train data, so I think our model cannot predict the data that doesn't have any traffic data. I'm sorry. Since the data on test data not only contains the ID but contains dates and hours, so I think our model can still predict those data considering the dates and hours.
Okay, but you mentioned before that you dropped all the IDs that are not available on the testing data. Is that correct?
Not like that. We on the train data, we create a dummy variable, so like one hot encoding, and the ID that doesn't exist on the test data, we drop that ID. So only the S2 ID, not all those three variables.
I'm sorry, I didn't quite catch that. So
Uh,
you did
okay.
drop the IDs from the that doesn't exist in the testing data. Is that correct?
Okay. I will correct that. Not IDs, but the S2 ID.
For Miss Alvina, there is any question for this team, Das Gulu?
So far for me, none. Actually, the other judges has asked. Yeah.
Okay, then probably another question from me. Can you reiterate one more time the conclusion or the recommendation for the provincial government of Jawa Barat based on your prediction or based on your model?
Okay, the conclusion is on West Java, Bekasi, and Depok, and the most congested city is in Bekasi, followed by Bandung, and the most congested hours is at 17 o'clock or 5 p.m., followed by 18 p.m. or 6 o'clock. So maybe the government can sort out the traffic at that hour to make the traffic more good. Okay, that's all. Thank you.
Thank you.
Okay, thank you to the judges for the question and Das Gulu for the presentation. I wish you all the best for the result. Okay. Hello, data people. Welcome back to Data National Hackathon. Before we start, kindly reminder to all the judges and presenters to raise your voice volume. Thank you. Now it's time for second team who will be present their ideas. Please welcome to Data Science Everyday. Hello, guys.
Hello.
Hello.
Okay, thank you. There are three amazing participants in this team, including Aldo Leviero Irviansyah, Novia Permatasari, and Muari Yaska Ginang Prasidana. To Data Science Everyday, please present your ideas. Good luck.
Okay, let me share the screen. Can you see the screen? Can everybody see?
Yes. Okay. Hello everyone. We are data science every day. Okay. Let me introduce the team member. I'm Wargiaska with my friends Aldo Leviro and Novia Permatasari. In this opportunity, we would like to tell you about our work and ideas. Next. Okay, first of all, let me start from overview information about this task. Next. Okay. The problem is Swiss Java has started facing traffic jams in several cities. And then what should we do? With traffic data, we are given tasks to build a machine learning model to predict high jam reports. And the metrics that will be used to measure the performance of the model is F1 score. And the next action after the model has finished being developed is Java Digital Service and the local government in West Java will make policies to reduce traffic jams based on the model. So we must make the model easily to be deployed and implemented in real cases.
Next, I'll tell you about data understanding and preparation. First, we'll look at the data train and data test. Data train consists of data since 1st of September until 22nd of November 2020. Data test consists of data since 23rd until 29th of November 2020. It shows that data train and data test consist of different date interval. There is two features in data train, IDS and label. In the IDS feature, which is composed of S2 token level 15, dates and hours, we extract two IDS token, IDS date and IDS hour. In the label feature, we encode false to 0 and true to 1. It can be seen that there is a difference in the distribution of the data train label true and false, or commonly known as imbalanced data. There is no missing value on both variables. By converting S2 token level 15 to longitude and latitude, we can see the distribution of the data train on the map. It can be seen that the data spread in the Depok, Bekasi, Bogor, Bandung, and the surrounding areas. It is also seen that the observation form a line that can be inferred to be road. Next, we do time feature extraction. We extract four new features, namely hour, day, weekday, and month. Based on target analysis, we investigate the differences in distribution of each time feature based on the categories of the dependent variable. Observation labeled true are mostly found during rush hour in the afternoon on Saturday and October. Meanwhile, observation labeled false are mostly found in the morning and afternoon, but it is more uniform across day, weekdays, and months. We also explore data alert and irregularities. We found the same time pattern of data irregularities, alert with type gem, and data train with label true. Actually, there is a difference in our pattern of the data irregular and alert with data train, so we add them by 7. This time feature become the basis for grouping data alert and irregularity before being joined with data train. Next, we compare IDS token level 15 in data train and data test. We found 85 IDS token and 312 records in the data test doesn't exist in data train. To overcome this, we extract IDS token until level 6, which all IDS token are the same at level 5. Last, we did M-estimate encoder. This is a simplified version of target encoder, which has only one tunable parameter M that represents the power of regularization. The example of M-estimate encoder can be seen on the slide. To summarize data preparation, we show you a pipeline of pre-processing data. First, we do time and token level feature extraction in data train, data alerts, and irregularities. Second, we do M-estimate encoder to process data train to get pre-processed data 1. The data train also joined with data alerts and irregularities by time feature. Then we do M-estimate encoder to get pre-processed data 2.
The next part is modeling. Uh, Before that, let's talk about validation strategy. In this project, we use strategy that combines stratified K-fault, cross-validation, and output prediction. The stratified K-fault method is method by dividing data into equal parts by maintaining the sample percentage of class label. Meanwhile, out-of-fault prediction is technique that use and combine the prediction result for each class fault, that the prediction result for the entire data are from. It is also used on the prediction step in data test, which takes the average value of the prediction from its fault model. Then, in this modeling process, rather than using the default threshold, we use the optimal threshold to decide the class label from the prediction probability. To determine the optimal threshold, we use Audience statistic method. This threshold value is useful for optimizing the accuracy, precision, and recall metrics that indirectly affect the cause metric F1 score. Before deep diving into modeling, we propose to experimental scenario of feature usage. Because if we take a look at feature implying important in cat-based modeling, the top ranks are dominated by feature from data trend. So in order to see significant influence and simplicity models, we divided into scenario A that only use feature from data trend or pre-processed data one. And scenario B that use additional feature from data alerts and irregularity or pre-processed data too. Then the patterns of modeling that apply to each of the two scenarios mentioned before. First, we do feature selection using the backward selection method with reference to feature rank important in cat-based modeling and the result of F1 score matrix. Second, we do the classification modeling using cat-based algorithm which produce the prediction probability of cluster label. Third, we compute and determine the optimal decision threshold to get class label from the prediction probability. Fourth, we do the hyperparameter tuning using Optuna framework and get top 5 rank model hyperparameter, which then we do the cat-based modeling of each of those parameters. Fifth and last, in order to improve the possibility of increasing the matrix performance, we also do ensemble using majority vote from some of the previous model. Based on the previous explanation, here are the results of experiment that we have done in edge modeling scenario. As it can be seen, that scenario A perform much better rather than scenario B, both in local CV and calculated work. Even the single base model stand out rather than the assembled voting.
Okay, let's move to topping or additional feature. Next. For the model output, we try to make more segments or levels so Java Digital Service or local government can see in detail and clearly the change after doing treatment. From there, we can evaluate the significance of the change that is influenced by the treatment. In addition, this makes it easier for Java Digital Service and the local government to analyze traffic jams and plan the right treatment for its output segmentation or level. These models users are not only Java Digital Service or local government, but also common people who need to know where way they can pass. So this model output will be easier to be understood by common people. The method we use is optimal binning, which considers the event rate of actual target value and the weight of evidence. It can be seen from the graph. The higher the segmentation or level, the more the actual target value is 1 or 2. Next. And last, I come up with the conclusion. Next. Between two scenarios, scenario B has more cons or negative sides, which must be highlighted is about data availability and how to gather the data in future implementation. As we know, scenario B use data alerts and irregularities which are obtained from external parties. In implementation, it must integrate the system to send the data from external parties such as API. Moreover, it will be complicated in gaining legality from the external party and it may spend more money. Based on what I have told, we prefer to recommend scenario A, which will be easier in deployment and data gathering. Besides that, scenario A also has a better result in matrix F1 score. What we can learn from building the model is time and location features with the right preprocessing and modeling are already good enough to predict traffic jam pattern in West Java. Next. Okay, let's move to the dashboard. We have built a simple prototype dashboard to show the output of the model at a certain time and place. On the right side, we can use the bar to filter, and for the output, we use we already used the optimal binning result to show the level. Okay, maybe back to the presentation. And then for the last, it's the my visualization day by day and maybe just for fun. That's all from us. Thank you.
Okay, thank you so much to Data Science Everyday for this presentation. Now it's time for Q&A session. For the judges, is there any question that you want to ask to this team?
So I have a question actually. So I think the team concluded with saying that scenario A, which is based on time and location features, are good enough to kind of predict the traffic jam patterns in West Java. I think because in scenario 2, you have to kind of integrate with the Waze API, which has all the other more complex information. I was just wondering if you don't actually, how do you even get the training data set if you, because in the training data set, you have the location, the time, and the hour, and then there's a label that's true or false, which denotes traffic jam or not, right? But how are you going to get that if you are not if you cannot rely on external parties? So how would you get that on a continuous stream? Because one way to get this is to look at the waste report, look at the alerts, and then you say there's a jam or not, right? Or you look at Google traffic flow and you see whether there's a jam or not, and then you get that report. But that is pretty much external.
Okay. Actually, we just have we can call it like behavioral variable like that. So we build the model based on the behavior of maybe the location and the time like that.
But how are you going to collect whether it's a jam or not at that time and space?
Okay. Actually, it was provided by the committee that the data it was already labeled, and so we just use that actually.
All right. So no more questions for me. Thanks.
Okay, thank you.
Is there any question from the other judges?
Check. My question is the same as before. Based on the data, we can conclude the traffic behavior between cities different. Please give me a recommendation.
Like segmentation or level like that to maybe segmented the what we call it the level of the traffic jam. So maybe what can I suggest? Maybe one location can learn from another location that have the same segmentation like that, and maybe another suggestion is we have make segmentation. So maybe each government can make a research like just try to give a treatment, and we can observe it in the future. Is there any change based on the segmentation like that? So actually with the segmentation, it make doing research will be easier like that.
Okay, thank you.
Okay, question from me. First of all, thank you, Team Data Science Everyday. Very good explanation on the presentation. Can you show me again the dashboard and like how would like, for example, the transportation agency at Jawa Barat can use the dashboard? How would they use it and on every day?
Okay. Maybe the user can adjust or maybe like doing filter with the bar on the right side, which the filter is by location, by hours. Maybe my friend can add.
Oh, maybe you can see that there is some pattern that high jam happen in some crowded city and areas. So we can do some treatment like in the neighborhood for size like to handle this problem. So it depends on the level and the crowded place, crowded area.
So the dashboard only shows the existing data, right? Not the prediction.
Yes. Yes, the data. So the exit data and the prediction in the test data. So if we are some traffic latency, we can see the future data that happens in the future. So we can do a treatment based on the prediction, like where the area that have high jam and not based on business knowledge.
Yeah. So maybe it can show the historical data and in the future actually.
Okay, thank you.
I have a question for your team. Again, maybe thank you so much for your presentation. Can you tell me more about the feature that you use, like the token IDs that you have there? Can you tell me more about it?
Okay, let me explain. The feature that we use in the modeling is based on feature extraction from time and location, that we can see that there are some token level from token level 15 until token 16, and we can see that the feature importance is the highest has token hours, that day, and token for and so on. So based on that, we do some modeling with CatBoost.
Can you share again the top feature?
Okay, sorry, share screen.
IDs token, IDs hours, IDs dates, day. So you only use the token hours, right? Mm-hmm.
Yes.
Mm-hmm. What is token 14, 13, 11, 10?
This feature is
It's the level.
The level of S2.
Oh. Okay. You make a high more higher areas, right? 40, 13, 20. Okay.
Yes.
Okay, I see. What do you think the dates of day, hours, and token becomes the most influence feature?
Because we assume or we hypothesize that every location and time has the same pattern to happen jam. Like crowded city happen to be most and several times has high jam. So it's like the pattern is repeated for several location and time. So based on that, we think the model trained from the historical data have the same pattern.
Okay, the time is up.
Yep,
Okay.
okay. That's all from me. Thank you. Thank you.
Thank you to all the judges for the question and the data science every day for the presentation. I wish you all the best for the result.
Thank you.
Okay, thank you, thank you.
Okay, before we start the next step, Okay, thank you. Hello, dear people. Welcome back to Data National Hackathon. Now it's time for the third team who will be presenting their ideas. Please welcome to X Pegasus. There are two amazing participants in this team, including Nurtantio Kuidar and Alfian Rahman. To X Pegasus, please present your ideas and good luck.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Yeah, we are X Pegasus with me, Tio and Aleph. We are about to share our thought regarding to the high traffic prediction. Yeah, West Java is the one of the largest province in Indonesia. Over time, West Java continues to develop rapidly as West Java shares same issues with the other big province. West Java commends facing traffic jams in several cities. In fact, according to the latest report by Jabar Digital Service, Bandung is the first position of the most congested cities, followed by Bekasi and Bogor. Related to that problem, we are here trying to give our talk related to. Okay, first we want to know about the data distribution based on the flag that given. Started from the hourly data, we found that the highest report is coming from 3 p.m. to 6 p.m. that might be related to event where citizens doing much traffic activity like going home from office. From the monthly report, we found October that has the highest report on the distribution of the true and false flag is relatively higher than September and November also. The third one, tell us about distribution in the daily basis. So we know data is going higher start from Thursday and reaching its peak on weekend. Then we can see Saturday is contributing the highest report value, including it's the imbalances proportions. And fourth, we want to see how we can see the whole data in the term of weekly basis within month. From this, we know from the fourth week is having increment from the previous week, so it might be affected by payday, so it attracts citizens to go out for more and to make some traffic jam for sure. And yeah, coming to the last EDA part, we know we have some missing data that only exists on the train data, meaning we have to predict newly added S2 cell traffic on the test data. Then we also know we have imbalances proportion that we think we will handle it later. And this part is talk about report behavior that resulting false report from the 9 p.m. to 6 a.m. So we might call it the false hour. Yeah, coming to data processing part, we have three main process. We are flagging holiday, rush hour, and weekend, since we know that attributes are affecting the behavior that's shown from the EDA. And also we are extracting key feature, our key feature, which is Cartesian axis. So we can use it in the training part. Afterwards, since we have images on the data, then we decide to do the data upsampling using Smoothie, and then we split the data, and our data is ready. Okay. Some explanation for the feature extraction. We extract all the time-related value from the S2 IDs, and we take S2 IDs, doing some calculation, and that resulting the Cartesian axis, and that this feature will help us to predict data that is not present in the train data. And also we do data augmentation using Smoothie, since like mentioned before, we have we are facing some imbalances data, and this process will resulting this final feature. So we decide to make model more simple with this 10 features. We have IDs, hour, month, weekday, week of month, is weekend, is holiday, and of course our key feature is Cartesian coordinate X, Y, and Z. And for the modeling part, we are choosing simple and fast model, which is logistic regression, because the case here we are about to do classification, and we are using default sigmoid and decision boundary, so we can classify value into the class 1 if the threshold value above, and if the value goes below the threshold, Then we classify it in the class 2. Okay, come to the evaluation, we knew that there is a quite significant difference difference in F1 score between the non-SMOTE model against the SMOTE model. Yeah, before SMOTE false value in F1 score is low, meaning we failed to predict the false in the good manner. Then we have to do the upsample data to make a prediction more balanced. Yeah, the result is like this. And finally, we arrive at the conclusion, yes, we can use a simple model, logistic regression as our base model for the prediction for future high traffic. And the data treatment on the imbalances data has a significant effect for the prediction result. And also we recommend it would be nice to the model if we have all historical data for all S2 IDs. And also creating a time series model for each S2 ID cell is better instead of doing classification based on historical data. Yeah, regarding to that, we need more computing power since we have many S2 ID here. Yeah, I think that's all from us. Thank you very much.
Okay, thank you so much to Xpegasus team for this presentation. Now it's time for Q&A session. For the judges, is there any question that you want to ask to this team?
Hi, Abelvia. So thanks for the presentation. I do have one question on the slide that's on the breakdown of the true false for versus the 24 hours, and I think that's slide number 5.
Yeah, we'll share it again.
Yeah, if you could share it again.
1, 2, 3, 5.
Yes,
this one?
correct.
Okay.
I was wondering, why is that the case whereby at 9 o'clock you have all false and no truth at all?
From 0 to 6 is like the traffic is not quite high because it's everyone is sleeping, right? So it makes sense if the false it creates all false table.
Yes.
Mm.
That I will agree, but at 9 o'clock?
9 o'clock. Yep. So actually, it's based on our observation because it's in West Java, and especially the data after we research the data mostly came from Bandung, right? So mostly in Bandung, the traffic is from at after hours, so it's between 18 and 20. So it also makes sense if the hour between 21 and or 9 o'clock in the night until 23 is low.
Actually, my question is.
Oh, 9 in the morning. Okay.
9 in the morning. Yes.
Okay. So, okay. So if we talk in the morning, we use the data comes from the train data. So it's possible actually if we can get this data because it's train data, so it's not it's not picture it doesn't picture all of the data in the real, because we can select the part of the real data into train data. So it can it possible if it doesn't represent all of the data in the real case.
All right. Another thing is, do you guys consider a breakdown of the hours on each day, like on Monday, on Tuesday, and then on Sunday? And what are the results for that? Because I think if I'm a business owner and I want to kind of make policy recommendations, that might be one way that I would want to look at it.
Maybe Theo can go back slide to the weekly basis. Okay.
Sure.
Yep. Okay, so maybe later Theo can collaborate on my answer. Based on our observation here, in the weekend, except for Sunday, like Friday and Saturday, mostly the reports is higher than the weekdays. So maybe for the business users, seeing this result can be more focused on creating a plan for the traffic in the weekend, especially the Friday and Saturday where the results is high, rather than the weekdays.
All right. Thanks. That's all from me.
Yeah. Thank you.
Question from me. Thank you, Expegasus. A very good presentation. Can you explain the feature significance? I see that you are using the geolocation as well, right? The coordinates. Yeah, I want to see the significance of each feature in your model, please. Thank you.
Yeah. So because our team is using one hot encoder, so our feature is quite high. So we have around 19, 16 features. So we cannot plot it well. So maybe if you want to ask me about the significance of XYZ feature, which is here, it's not quite high, but it's useful first week of each month until the first week of each month. So it's the week of month. So if we see here, if the week is 5 or 4, or which is the last weeks of each month, the features become higher. The score become higher. So it makes sense because just like mentioned by Theo in his presentation, if we see in the pattern that in the 4th and 5th week of each month, the number is higher. It may be because of the payday, which is people will mostly go out for shopping or for traveling, something like that.
I would assume the hour of the day, but it's not. Can you explain that?
Oh, hour by the day. Okay, so for that question, we haven't do the analysis for the hour of for each day.
Okay, thank you. That's all from me. Thank you.
Sorry.
Okay. Mas Akbar?
Check.
Yeah, you can. Yeah,
I have a question. why do you use a SMOTE? Even though the data you use as an input variable is only related to the location and time. The reason why you use SMOTE.
Okay. First of all, we use Mote because we found the data is imbalanced. Actually, the label. We also already test the data. We tried to compare between without Smote and the with Smote data in the both of the train and test. And after we submit in the Kaggle, the score become higher. And it actually it depends based on the case, but we see that the effect of SMOTE on the test data giving us the higher result.
I think SMOTE is a method use a KNN concept by calculating a distance from the data. Why you not use a standard concept of undersampling or oversampling?
Okay. So for oversampling and undersampling, we can use some of the method. Then and SMOTE is one of them. After we tried some of the methods, so like undersampling or oversampling, we found still SMOTE is one of the methods in oversampling that gives us the good result. So we tried some other methods in oversampling.
Okay, time is up. Thank you for the judges for the question and Xpegasus team for the representation. I wish you all the best for the result. Hello, little people. Welcome back to Data National Hackathon. Now, it's time for fourth team who will be present their ideas. Please welcome to IMH team. Hello, IMH team.
Hello,
Okay.
dear judges.
Here comes the solo factor in this team. Say hello to Arifuddin Miftahul Huda. IMH team, please present your ideas. Good luck.
Okay, good morning everyone, dear judges. Hello everyone. I'm Arifuddin Miftal Huda from IHM team. I would like to present my project name logic classification to predict high jump in West Java. Before we jump into my project modeling, I would start from the case question, that is based on historical data of area, date, and hour in West Java, how to predict high jam reports in the future. So the first step, I do exploratory data analysis using heat map. In this chart, heat map chart, we can see that in the weekday, high jam is occur in 17 until 19. It is logical because people come home from work. But in the weekend, more hours affected by the high jam. It is also simply can be explained why, because in the weekend people tend to hangover, go to holiday, so the distribution of high jam more affecting in the more hours. And in the red circle, we find that there is an anomaly in the long weekend at the end of October. The distribution of high jam is spread out in more days and more hours. Because in the end of October, we have long weekend from Thursday until Sunday. Okay. From this exploratory data analysis, I also capture the period of the data set. We have two main periods. Period from 1 September until 22 November is a live data set, regularities data set, and data train. But the data test, the period is from 23rd November until 29 November. So based on the capture of the exploratory data analysis, my model use only data train as relevant data set, which features are token, that is represent the area, day, and hours. And my model uses if logic classification. It is my own name for my classification in this model to classify the data set based on feature on the data trend. It is just simply simple lookup function to predict or to look up a specific area in the stars, the day and the hours to identify the characteristic of those excluded IDS based on the similar IDS. For example, if some area that the data is not included in the data trend for Wednesday, we can use the other day that is similar characteristic of Wednesday. So the clustering of the day is as follows. We can cluster into three cluster. I cluster the day into three cluster. They are Friday, Saturday, and others day. Friday is second high jam report. I can explain why Friday is high jam, because Friday is the start before weekend. People to go to the home base from the city where they work. Yeah, and the Saturday it is simple to explain, because more people tend to hang over and make some traffic in the Saturday. Because we capture there is an anomaly in the long weekend of the at the end of October, I make a simple adjustment for the long weekend in the end of October. So the 28th and 29th October are treated as Friday, as the start of people to going to the city of their home base, and the 30th and 31 October are treated as Saturday. The cluster of hours, the distribution is as follows, and 17 or 9 p.m. is the highest time. So I cluster the hours as into 7 clusters to handle the undetected hours in some day in the specific area that is not included in the data train. This is my if logic classification, just simple lookup. If based on token day and hours, we can detect in the data train so we can give the label value is true. But if it is not detected in the data train, so we convert the day into the day cluster. So we can look up if Wednesday is not included in the data train, we can use the same day in the cluster of weekday to predict some area in the specific hour. Is there any report of high jam or not? And if the second step is still not detected, yeah, we move in the third step. We use token day and how our cluster. And if the third step is also cannot detect it in the third step, we also detect anymore with token day cluster and our cluster. And the final step, if all of the step we still cannot detect in the data trend, we conclude that specific tokens in the specific day and the specific hour is labeled as false. Because I jumped into my conclusion, I have three alternatives of detection. The first is I use modus of label. So if in specific token, specific day or day cluster, and specific hour or hour cluster, the modus is true, I will label it into true, vice versa. And the second alternative, at least one true, I will give the label as true, at least one true. And the final decision in the final alternative, and that is my conclusion, and I use it to my model, at least one report. At least one report, regardless in the data train, the label is false or true. I will give the label as true, at least one report. And this is my evaluation, F1 score of true, because my priority in this model is to predict the true label. The highest F1 score is the third alternative, at least one report, regardless in the data train, the label is false or true. So my conclusion is the frequency of reports in the past can be a good predictor of high jam in the future. That's all for me. Thank you, everyone. I will open for discussion. Thank you.
Okay, thank you to AMH team for this presentation. Now it's time for Q&A session. For the judges, is there any question that you want to ask to this team?
Probably from me first. Thank you, Mas Arif. This is a one-man show team, yeah. Interesting, unorthodox approach, I would say. Very interesting. I do have some questions about the precision and recall metrics. Can you explain a bit more about that? You have three different F scores. Yeah, can you explain more about that, please? Thank you.
Okay, thank you, judges. I will declare that my model is just only use Excel. I asked to the committee, is there any problem if my model is still in the Excel? The committee say that no problem. So I do not convert it into the computer notebook. So I will share my evaluation model on the Excel. Okay, this is F1 score for the third alternative. If so, if I change it into the first alternative, the F1 score is just 40%, yeah. And the second label lower, and the highest is the third alternative. It is just simple pivot table for the I compared my prediction to the actual value, and I use manual formula in the Excel to calculate the F1 score.
What was the label again? What does the label represent? Sorry, I missed.
Okay, label 1 is represent the first alternative on my model. That is, I choose the modus of the label. For the example, if the modus is true, I will label the prediction into the true, because true, the right side is true, yeah, the right side is true, and the left side is false. This is my first alternative, and the second label is I use at least one true, yeah, regardless the modus, or at the same token on the specific hour and the specific day is false, I will label it as true, at least one true. But in the third label, I just at least one report, regardless the label and the data trend is false, I will label it as true, at least one report. So my conclusion is the frequency of reports tend to be a good predictor to predict high jump in the future. My explanation is if in the same area in the past, in the specific hour and the specific day, there is at least one report, it can be an indicator to high jump occur in that area in the same day and the same hour. That's my logical in my model.
Very interesting, Mas Arif. Thank you. That's all from me.
Thank you.
Hello, Mas Arif.
Yeah, hello.
I'm wondering how do you do the prediction in Excel?
Mm-hmm.
Can you share it to me?
Okay. I share it again.
Yeah.
So it just it is why I name it if logical classification, because I only use if logic in the Excel. If A then 1, if B then true, if 3 then that's all. The logical is in the alternative one, if the modus of the token of the IDs in the data trend is true, so I will label it as true. Vice versa. In the second alternative, the logical is if at least one true in the IDS in the data trend, at least one true, I will label as true.
Okay.
And the third alternative, the logical is if at least one reports, regardless in the data trend the label is false, I will give it label as true. Before I do evaluation metrics of F1 score, I assume that label 1 or alternative 1 is the good model, is the best model from my three alternative. But the F1 score say contradictory, but then that the alternative 3 is the best, have the best F1 score. That's my explanation for my model if logical classification.
Okay. In your classification, there is in the last part there is a not detected. But what happened? The not detected is for false, right?
Okay. Yeah. Betul. It is correct. It is correct.
Okay.
I assume that there is no report in the specific area, specific day, and specific hour. So it has no possibility to high jump occur in that area.
Okay. All right. Cool. Thank you.
Thank you. You're welcome.
Is there any question from Mr. Akbar or Ms. Alvina?
So I think I only have one question. So I think for the training data, for the testing data set, there should be some tokens that are not with the same spatial coordinates. So could you remind me how did you extend your method to those?
Okay. Thank you very much, Ms. Alvina. If we cannot detect some hours, I will change. I will use the hours cluster. So I will use the some hours that is similar to the hours that is not detected in the data train. SMS at the day. If we cannot detect Wednesday, I will use the data from this same cluster of Wednesday in my model. So I will use cluster of weekdays. But if we cannot detect tokens or area, I will conclude that that area is false. Has low possibility to occur a high jump, to affect a high jump. That's
Okay. Yeah, that's all from me.
Thank you.
From Mr. Akbar, there's 1 minute left if you want to ask something.
Enough for me. From me.
Okay, that's all. Judges, any question left? No? Okay. Thank you to Arif or I am Hatim. Also judges for the question. I wish you all the best for the result.
Thank you, judges.
Okay. Hello, data people. Welcome back to Data National Hackathon. Now, it's time for fifth team who will be present their ideas. Please welcome to Murid Pak Sigit. Hello, Murid Pak Sigit.
Hello.
Okay. Here come another solo fighter. Say hello to Ajar Parama Adi. Murid Pak Sigit, please present your ideas and good luck.
Okay, hello everyone. My name is Ahsan Paramadi. I'm from Team Murid Wasikit, and today I will present my results, the adventure of traffic congestion prediction in West Java featuring features. Okay. And for the prologue, let's talk about the problems. The task is to predict high jump reports using traffic data provided by the GDS in certain area and at certain time. From the problems, I constructed several hypotheses. The first is several locations should have higher congestion response rate than the others. Second, each location should have its own peak time. Third, if I getting near that location at its peak time, the probability that I'll get stuck in a traffic jam should be higher. Let's dig into the data. There are three data in this competition. The first one is pipeline test. The second is alerts, and the third is irregularities. Actually, we can join the three of them, but there will be missing values. So how I handle the missing values? I look through the data started from smaller time frame like hour and location like SSL level 15 going up to the larger time and location dimension. And from that, I get the static features and lag feature. Additionally, I can also get the statistical feature like min, max, and it will be ton of features. So let's do the feature engineering and let the fun begin. So I did mix all the things because bigger is better, right? And I cut for around 230 features. And picture in the right is the correlation metric. From that, I filter my features and left with around 50 features. And then what? For modeling part, I just mix and match features, doing grid search, and then submit to Kaggle. And the result is not good. Actually, that is bad because I got no improvement at all. So did I really understand the problems and the data? The answer is no. And then going back to the hypothesis, the things that should matter are first, its location should have its own characteristic about congestion rate. Second, its location should have its own busy time. And third, distance and time difference between locations. So let's dig into the data again. At the daily traffic reports activity, we can see that there is seasonality. For every week, there are spikes. You can see in the orange line here that every weekends there are spikes. And also in the end of October, there are holidays. So we can add weekends and holidays feature. From the hourly activity, we can add last hour feature. From weekday, we start from 7 and end at 20. And when the weekend, it starts from 10 and end at 21. And then for the location, I do clustering, and the result is 3 cluster. This is the big set of cluster around Bekasi. The blue one is the low congestion rate area. The orange one is the medium, and the yellow one is the high congestion rate area. And for the addition feature, I create a custom function that measure the distance and time difference. First is from the nearest high congestion S2 cell, and the second is to measure the distance and time difference from nearest low congestion S2 cell. And from that, I cut around 6 features, that is from distance in kilometers, time difference, and congestion rate. So for the modeling part, I use like GBM. First, I do time series speed plus validation because the data is weekly time series. And to help my class validation, I create a baseline model. The baseline model is only written to class and calculate F1 score from that model. So for example, if I set it all to true, the result is 0.8. And I assume that my model is getting better if the F1 score is higher than the baseline F1 score. And the next step is visualization. So does the visualization make sense? In the right and in the left, in the left is the my previous model, and we can see that in the middle of the night there are reports about traffic jam. It just doesn't make sense at all. And at my final model, we can see that at the middle of the night there is less reports of traffic jam. And then for the last, I try to reduce the features. So from start, I got around 200 features and going to 50 features, and I go to fewer and fewer features. And at the last, I got around final 12 features. I use LE5 to determine the weight for each feature and remove feature that is the weight is low. Stay under the feature set, back to class validation and compare the result. If the result is better, I try to submit it to Kaggle. And this is the final feature by its importance. The most important one is cluster. And I got private leaderboard score for around 0.67. So for the time clustering, and then if possible, add another data such as leader and pollution rate. And then for the government, they can place IoT sensor devices on high congested area. And for GDS, they could use this prediction to help creating like alert system and then optimizing traffic light management and determining CCTV location. And last for the closing statement, I got a quote from John von Neumann. With 4 parameters, I can fit an elephant. And with 5, I can make him wiggle his trunk. So it means that adding more features doesn't always produce better model. Sometimes less is more. Okay, thank you. That is my presentation.
Okay, thank you so much to Murid Pak Sigit for this presentation. Now it's time for Q&A session. For the judges, is there any question that you want to ask for this team?
There are a question from me. Mas Ajar, for example, if you are allowed to retrieve data outside of the existing data, what data will you use?
I think if I can, I will use the speed for what is it? Common speed, regular speed that car is car in that area and the drivers can. But in the competition that is only irregular latest data. If I can have the normal data from the alpha vehicle or alpha vehicle, I think I could improve my model.
Ajar.
Is there any question for Narjas?
Okay, Mas Ajar, thank you, tim Murid Sigit ya. I do have a question about the conclusion. You mentioned that in the conclusion that there are specific features that are important, but can you elaborate more on the insights or based on your modeling? What can you say? I mean, if you are talking to Pak Gubernur Emil gitu ya, what would you say based on your modeling or your data exploration?
Okay, thank you, Mr. Andian. Actually, if I look into my model, the most important feature is the cluster. So if I am the governor or I'm the governor of West Java, I'll focus my policy on the area that is have high probability getting traffic congestion. So in my model, that is the yellow cluster, if you can see in my area, we can place the CCTV. So police on the other government agencies can monitor the road more effectively. And I think that is my answer.
Okay, thank you.
Hi, this is Elvina from GovTech. Thanks for the presentation. I like the fact that you did additional feature engineering in your work here. I was just wondering, I think because you took the measurements from the target area with respect to the next congested area and the next not congested area. This is just a simple straight line distance, right? It's not with respect to the roads or any road network, right?
Okay, thank you, Miss Alvina. So actually, I just mentioned the slight distance. I don't count the lot distance. I just mentioned the slight distance.
So I was just looking at slide 11. It looks like the congested area seems to be kind of line out along
description, I cluster based on weekend status. So if the that set if a location that is near another location in a weekday and that high probability of getting congestion, it will be in a same cluster, I think.
I see. Okay, yeah, that's all from me. Thanks.
Okay.
Do we still have time, Tama? Okay. We still have. Okay. Mas Sajat, thank you so much for the presentation. That's a great content you have there. I want to know more about your modeling. You use like GPM, right?
Yeah.
Have you tried to use another modeling maybe or like a logistic as simple as logistic regression? Have you tried that before and you compare it or just you directly use the like GPM?
Okay, thank you, Mr. Alamsyah. Actually, I haven't read any other model, so I choose only LGPM. Why? Because I think it's often medical users use it at the competition, and some of them win with the LPGM. And another reason is this competition is this competition have limited time. So if I compare it with another model, it means that I need to treat my data differently based on that another model. So it will take more time. And I think that it is better to focus on feature engineering, creating more meaningful features than trying another models uh, I'm not sure that it will be better. Thank you.
Thank you. Thank you, Mas Fajar. So in here you have 237 features in the
Yes.
beginning, right? Out of that features, what features that unexpectedly not giving impact on your model, but you thought it will be, but it's not in your model. Well, what is it and why? What do you think?
Okay. I think it's the feature about speed and traverse count, but from the irregularities data. I think that if the speed is decreasing, it will be result in two class. And if the traverse count is high, it also will be lean toward positive class. The correlation is just too low because I think the data is from the irregularities data, and I don't have data from the normal one, normal speed and normal travel score. I just fill the NA values with nearest possible location at the nearest time bias to the model.
Okay, thank you. Thank you.
Okay, the time is up. Thank you to the judges for the question and Murid Pastigate for the presentation. I wish you all the best for the result.
Thank you.
Now, it's time for sixth team who will be the presenters' ideas. Also, the last team on this first session before the break. Please welcome to Lulus 2021. Hello, tim Lulus 2021.
Hello. Okay.
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 There are
Okay.
two amazing participants in this team, including M. Farhan Tandia and Ivan Surya Hutomo. Tim Lulus 2021, please present your ideas and good luck.
Okay. Good morning, everyone and judges. Today we are from Lulus 2021. We want to present about our method in Data National Hackathon. So this is our outline today. Let's go to business understanding first. So why now we need data science in Indonesia? First of all, because we already start smart cities development in Indonesia, especially in West Java. And from this smart city development, it's better to starting with better traffic and data-driven solution. So we need a greater use of many data in traffic jam, so we can hopefully predict the forecasting for the future with the data. And hopefully with this prediction, we can help government to make a better decision about what government gonna take for a better traffic. Okay, next we gonna explain the data explanation. So this is our task. So using traffic data provided by GDS, we want to predict high jam reports in certain sector. For example, in Bandung, in Ahmad Yani Street, we want to predict whether at 5 p.m. traffic jam occur or not. And the dataset we will use is, we have optional dataset. We can use alert report or irregularities report. And our main dataset will consist of around 70,000 rows, while the data test will consist of around 13,000 rows. And the target variable will be a binary classification. It's true or false. The evaluation matrix we use is F1 score. It's an equation that considers recall and precision as a score. And this is our exploratory data analysis. So we plot our data train within the label, and we can see here that our labels actually imbalance. We can see here that the true labels has almost 47,000, but the false label only half of them. And also we plot our data with label and hour, and we can see here that the traffic jam mostly occur on 5 p.m. And also for the day and label, we also see that most of traffic jam happens on Friday and Saturday. And we also plot our labels within some area, and we can see here that our data within some area also imbalance. Some of area have really many labels, but some of them has really few labels. And this is how we pre-process the data. So first of all, this is our raw train data. We have IDS and labels. And then we encode the labels to Boolean representation. In this case, true is 1 and false is 0. And then we split S2 token 15 to S2 token, publication date and hour. And after that, we convert the date to days using Panda calendar database. So we convert, for example, this date to Wednesday. And then we convert S2 token to latitude and longitude using S2 cell library in Python. And we encode hours and days to categorical integer. For example, Sunday is 0, Monday is 1, and etc. And then we drop unnecessary column. And we also try to reduce data frame for better training speed. And we can reduce 22.6% for the data speed. And finally, we have final train or test data. We use 4 features for our training data. Here we use hour, day, latitude, and longitude. Hour and day as a categorical features, and latitude and longitude as numerical features. Okay, next, why we use 4 features instead 12 features? So actually, we already tried to use the features from alerts.csv. We try to use 12 features, but we see that our model is not better than if we use 4 features. So finally, based on our EDA also, we decide to use only 4 features that already represent the dataset behavior. For the next model will be explained by my friend.
Okay.
Okay, I will talk about the modeling and evaluation. So this is the machine learning modeling pipeline. Start, we use data train and do pre-processing. And after that, we apply to machine learning model in this part. We also do hyperparameter tuning, model selection, and feature selection. After we get the validation score, if we got a lower validation, then we go back to data pre-processing step. And if we get higher, then we can test the model with our testing data, and we do the submission. If we are not getting higher evaluation score, or we still not to becomes the highest public leaderboard, then we keep trying to do the machine learning modeling. And if we achieve the highest score, then it will become to an end. And this is the model selection. Actually, because we only use less features, then we focus on did an extensive experiment with machine learning models. As you can see, we use 6 different methods such as LGBM, MLP, FastAI, Node, CatBoost, and TabNet. This research is basically we search for the state-of-the-art model for tabular data. We split the data trend evenly. As you can see from those all models, the CatBoost has the highest score before and after the hypertuning among all the models. We use the Optuna as the hyperparameter tuning, so we decide to use CatBoost as our best model. And also we built some machine learning techniques to compete the CatBoost. The first one, we use a multi-layer perceptron and plus CatBoost. This is we use multi-layer perceptron, then take the intermediate layer to train again in the CatBoost. And the second techniques is we do the stacking ensemble learning. We define the best model such as extra trees, random forest, LGBM, and CatBoost. After that, the result will be input to the meta model. We use logistic regression, and the learning is use threefold cross validation. But still, the CatBoost can still unbeaten with our own techniques. So we will choose CatBoost in the next experiment. And this is the model evaluation. The hyperparameter, as you can see in the PPT, and in this is the hypertuning techniques that we consider as our last techniques to make higher accuracy. But after trying to do the imbalanced data set, we still cannot get high accuracy. We do the reweighting, undersampling, and oversampling. And then we try to use only using a simple split and if we increase the split ratio, our accuracy will be increased. Perhaps it be because of the model have more training data, less training data, so that the model will be becomes high variance. But however, for the leaderboard, we assign for the accuracy in hyperparameter split using CatBoost on ratio 0.5. But after we do more experiment, because we realized that we still not yet assign the categorical features to our CatBoost function. After that, we get higher accuracy. And moreover, after we try using stratified k-fold with k equals to 5, we also get a little high of accuracy. So this is our evaluation and last or final result that we achieve. And this is the conclusion and suggestions. For the conclusions, the CatBoost has the highest accuracy among all the models and also has the benefit on the robustness of using categorical data features. With only using 4 features, our technique or model is able to achieve a fast yet comparable accuracy on the leaderboard. Nonetheless, is not much features could be used rawly. To get higher accuracy in the future, well-feature engineering is required to apply on dataset. And lastly, this is the suggestion, as we know that the highest peak of traffic jam occurred in the evening and the weekends. Perhaps this model prediction could become consideration of government to create a new public transportation route and schedule that match with where and when traffic jam occur. And for
Okay,
people,
the time
let's
is
make
up.
okay.
Okay. Thank you
Thank
to
you.
Lulus 2021 for the presentation. Now it's time for Q&A session. To the judges, is there any question that you want to ask to this team?
Check. Okay. I will ask to your team. What do you think about the weather data and the calendar variation data? Why don't you add it as an input variable?
Okay, for the calendar data.
Calendar variation.
Calendar variation. You mean the calendar variation is like?
Calendar variation is a condition of a day. If might be in a long weekend, we can make a dummy variable for it.
Oh, I see. So because actually our data, our classification is not time series, we use classification method. So we only label our data set with this one: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. And hopefully, from this one, our model can train based on classification, so not from time series. That's why we didn't like make the Saturday and Sunday as a special weekend, like in the time series method.
Why about the weather data?
Weather data for weather data, we didn't use the weather data because last time actually we already tried to use all of the features, but our model is not reached better result. So that's why we didn't use all of the features.
Okay, thank you.
I have one question for the team. So I think you did some feature engineering initially, and then you landed on just using 4 features instead of the 12 features. And then you went to use machine learning to kind of figure out which one is the best machine learning models to use. I was wondering if the team has considered maybe the less advanced techniques, like just looking out at doing a k nearest neighbor with respect to your 4 features that you have found in the first step.
Actually, we already consider some feature engineering, but unfortunately, we cannot get a suitable meaning to the data so that can fit perform best to our model. So it will not get higher accuracy. Perhaps our feature engineering is not still need to improve for that. Thank you.
So I am not sure. So is the data sufficient to support the multi-layer perception and the tuning that you subsequently use, or is it too little data? I'm not sure how big the data is.
Okay, for the data it contain around 70,000 training data. So for the input of our neural network, we use 4 features, and then for the prediction we use the labels true or false. So I think 70,000 data maybe it's already enough for deep learning method.
But
if we have more
it
data,
should
it should
be
be
better to
better to
use
use
deep
deep
learning
learning
than
than
machine
machine
learning.
learning.
Maybe
Maybe
we need more
we need
data
more data
for
for
deep
deep
learning
learning
method.
method.
That's
That's
why
why
our
our
deep
deep
learning
learning
method
method
is
is
not
not
better
better
than
than
machine
machine
learning.
learning method.
Okay, thank you.
Okay, hi. Thank you, tim Lulus 2021. Very comprehensive presentation. Have you explored more on why the features, the 12 features, are not contributing enough score in your model? I mean, have you explored a bit more on on the feature itself? Are there any approach that you have tried, like somehow encoding it otherwise or making it as an ordinal data, or what have you tried? What have you explored?
Actually, we already joined the alerts data to the training data uh, based on the token. But after we join the data, there is a lot of missing value for after joining those data. So it also affect the testing data if the location is not occurred in the testing data, then our model it cannot get a high accuracy. And also, we have already tried to use less training data than the actual training data we have, and it get worse. But we also expect that if we do a well feature engineering or something fancy statistics methods, perhaps we can get high accuracy than current current accuracy. Yeah. So
Okay.
that's why we focus only on the modeling part.
Okay, thank you.
Thank you.
Halo, tim
Halo.
lulus 2021. I have a question about your partition. You do the validation, right? 80-20, right? How do you split the data? Is it random, or do you have any special splitting?
It's only random for the split. Yeah, we use random split.
Okay, why?
We use random split because our method is classification, not time series. So we can use random shuffle for our dataset. But if we use time series method, we will not consider to shuffle the data.
Okay, so yeah, because you're using longitude and latitude, right?
Yes.
What happened if has a higher an area that doesn't exist in training? Yeah, that's kind of a problem that I find if you are using only randomize the data. Yeah,
But actually, because we also use the numerical data such as length, latitude, and longitude, maybe the model can also find the similarity. I mean, the distance between latitude and longitude for the traffic jam. So actually, the cat boost itself not only consider the categorical, but also, I mean, the categorical features like day or hour, but it also consider the numerical features.
Okay. Thank you.
Thank you.
Okay, that's all. Thank you to the judges for the question and Team Lulus 2021 for the presentation. I wish you all the best for the result, guys.
Thank you.
Hello, data people. Welcome back to Data National Hackathon. So, we have to end this first session. Thank you to 6 amazing teams, also those judges for those amazing comment and presentation. After lunch, we will continue in second session to see another 7 teams who present their ideas. See you after the break. Welcome back with me, Zulfikar Istama, as the Master of Ceremony. Today, we are back in the final session of Data National Hackathon, or Danton, our first data modeling competition for all data science practitioners and enthusiasts from Data Science Indonesia community. And Danton is one part of Data Science Weekend 2021, a 3-day event dedicated to data tech and enthusiasts. Before we are going back to main session, we are happy to announce that our event are supported by many great sponsors such as Microsoft, S3, Data Academy, IKRA, and special thanks to Jabar Digital Service as our main partner for this competition. Also, from community partners such as AI for Impact, Female Jig, AIML, and Ladies, Deep Tech, the SCUI, their ideas. Please welcome to the Moon team. Hello guys. There are three
Hello.
amazing participants in this team, including Christian Wibisono, Ilham Firdausi Putra, and Adrian Novito Setiawan. Hello to the Moon team. Are you there?
Yes, we're here.
Okay. To the Moon, please present your ideas. Good luck, guys.
We cannot share our screen.
Admin can help them to become a co-host. Okay. Thank you.
Okay, let's start. Good afternoon, the honorable judges, ladies and gentlemen. We are from To The Moon would like to present our entry for Data National Hackathon entitled Predicting the Arrival of Sikomo on the Streets of West Java using Gradient Boosting Machine. If we hear about traffic congestion, the first city that came to mind must be Jakarta, right? But did you know, based on the latest study from Asian Development Bank in 2019, Indonesia's most traffic congested city is Bandung, which is located in West Java, followed by other big cities like Jakarta, Bekasi, and Bogor. Traffic congestion has become one of the problems of the modern life in many metropolitan areas, and traffic congestion actually kills, according to many research and studies conducted. It creates more pollution, it directly affects our economic productivity, several interesting insights where seasonality appears. The first one is the monthly seasonality, where we can see the decreasing trend over week of month in September and November, and increasing trend for month of October. And the second is the weekly seasonality, where the number of high reports and irregularities phenomenon often peak every Saturday on the weekend. And the strongest one, the daily seasonality, where number of high reports often peak in 5 to 6 p.m. Our hypothesis is because an after office hour where people going to at home at relatively same time. We also see external factor that are causing the irregular spike in number of high reports. For example, in 28 to 31 October is a national holiday and it's a long weekend. It's affecting the number of the congestion itself. From the spatial perspective, our data only cover for major cities in West Java, named Bandung, Bogor, Depok, and Bekasi. And we also observe that high report in certain area will directly impact its neighboring cell, as it often appears to be a connecting roads. For example, in Bandung, if the Langsung district is congested, Juanda or Dago Street is most likely to be impacted, as proven in the training data itself. Beyond seasonal and spatial pattern, we also find several criteria that also significantly impact the probability of the traffic congestion in certain areas and date. For example, is the recency effect by location that high has higher ratio of congested in the last week has also higher probability of congested too. And the second is the type and the accuracy of the report. And the third is the severity of the irregularities. All these criteria will be our rationale for creating more features and infusing more knowledge to our model later.
Next, we move on to data processing. We calculated the label count and we found that the distribution is uneven. This may pose a problem called cold start problem, where a model cannot predict correctly due to information insufficiency. Furthermore, there are some tokens in test data only exist one time in training data. Even some of them never exist at all. This may lead to a failure in false label prediction. To address those problems, we came up with an oversampling strategy to introduce more false labels to the data. The main idea is to get any tokens which are exist in the test data, but only occur once in the training data. We then extrapolate the labels 1 week or 7 days before and after every hour with the false labels. As a result, the amount of training data increased for almost 2 times its original value. We hope that this method will help the model to predict better, especially when predicting rarely occurring tokens. The next feature we can extract from the data is called multi-level spatial temporal features. In predicting traffic jam in the real life, we usually take some nearby areas into consideration. We believe that any event happening in nearby area will influence the circumstances with the area of prediction. For example, when predicting traffic jam in Taman Sari Junction near ITB, we will take also any alerts and irregularity data of its parent token up to level 9. That will include Dago Street, Dipati Ukur Street, or even Laing Pasupati Street. Multiple data for its unique IDs are joined together by mean operation. We then come up with an acronym SARS, seasonality, accuracy, recency, and severity, to summarize all extracted feature. Seasonality is talking about weekend, hour, day of week, rush hour, etc. Accuracy is talking about those features taken from alerts data. Recency is talking about any alerts and irregularities happening in the last 1 and 2 weeks prior to the prediction date. Severity is talking about those features taken from irregularities data.
Next, let's talk about the evaluation metrics and strategy. On the left, you can see our cross-validation strategy, stratified tenfold cross-validation. We have developed our feature in such a way that it is agnostic to the date and month for each data point. We encode all of the information that we denote as SARS in a single row, hence we can use this as our cross-validation method. On the right, we use standard metric for the competition, F1 score, balancing both precision and recall. But as we will talk about later in the end, the cost of misclassification is not equal and it varies depending on the use case. Next, model performance comparison. On the left, you could see the table divided by first the dataset type, A denotes the original dataset, and B oversampled dataset. And second, the model. Here, we can point out 2 things. First is that gradient boosting tree outperforms other model variants such as linear, decision tree, and probabilistic by a significant amount in both cross-validation and public leaderboard. And second, our novel oversampling and separating the model by per city cluster. And in the end, our best performing model is full trained with a private leaderboard of 0.87 that places us third on the leaderboard. Now onto the right side. Although gradient boosting model is infamous for being complex and act like a black box, using SHARP, we can analyze and interpret our model not only on which feature bring the most impact, but also on which direction is the impact. And we can even go up to each individual prediction level. We would love to talk about the insight from SHARP later on the Q&A if you'd like to. Next, beyond this competition. While not allowed in this competition, incorporating external data proven to be useful in performing the model performance. We could leverage data such as weather data from NOAA, route information and population density from Open Data Jabar, and trip data and driver trip from Grab Posisi dataset. After the competition ends, we played around a little bit with the external dataset, and we found that adding NOAA weather data improved the performance on the public and private leaderboard. Next, a model is only as valuable as its application. And here we propose Jabar Crowd, a real-time intelligent traffic flow monitoring system for city in West Java. It could act as first, an early warning system for traffic congestion. So for example, before Dago gets jammed, We could dispatch the necessary resource ahead of time. And second, as a decision support system for urban risk assessment and traffic management. So before we implement a road diversion policy, we could survey the potential diversion over the web and ahead of time. Lastly, let's talk about the use case that we talked about earlier. Cost of misclassification depends on the use case. And here, for example, if we were to implement a road blocking or diversion policy, we might want to optimize for position because it's more risky and increase the threshold. But if we want to optimize for recall, we might lower the threshold and use it to dispatch police instead. So last, to conclude, there are 4 cluster of features denoted as SARS that can best predict high report and irregularities on certain areas at an hour. Second, our novel oversampling method proven to be effective to make the model more robust to cause a problem. Third, the best performing model is the gradient boosting tree model. And lastly, we hope that our predictive model can be used as an early warning system and decision support system to formulate policy for West Java government in the future. That's all from us. Thank you for watching.
Okay, thank you so much from Team To The Moon for this presentation. Now it's time for Q&A session. For the judges, is there any question that you want to ask to this team?
Hi, let me start first. Thanks for the very nice presentation. I really enjoyed the work. I thought it was well considered, and I think the team has kind of thought about the different aspects. I only have one very simple question, and that is really about I think on slide 7, where you mentioned the cold start problem, and you also notice that in the training data, there are some tokens that only occur one time. And I think here what you did is to really backfill the data 7 days backwards and 7 days forward, right? I just have one very simple question. And the question is really why only for the tokens that appear one time? I would imagine that there are data set whereby is also unbalanced in this way. And I guess my question is why not fill up all the tokens this way with all padded by all the force?
Okay. Thank you for the question. Maybe Ade can answer that.
Okay, thank you, Christian. So basically, to why we didn't include the other tokens, the reason is just we did not want the trading set amount to be very big. So we prioritize the token that are rarely occur first. And then moreover, we can extend to the other tokens while improving the model as well.
Okay, thank you. I think that I think there might be an assumption that is kind of being made here, saying that if the data is not there, then it is most likely not high traffic. And I think if you actually study the time of the day versus the number of traffic, the report that's made, you also see that. I guess, but if you just backfill the token that occurs once this way, what will happen? Will it be the case whereby you really kind of bias it such that any other time, so if you just backfill everything as false, would the observation really be lost in your model?
Oh, okay. I think the reasons why we only use the rarely occurring token to extrapolate is we also want to maintain the distribution of the true and the false labels in the training dataset. So if with this assumption that if we fill the gap, assuming that there will be no congestion in those specific ID, I think that is the reason why we prioritize this kind of things. So for every sample, for every fault in our cross validation is also keep to keep the distribution of the labels itself.
All right, thank you. Thanks for the presentation. Yep, that's all for
Okay,
me.
thank you for the question.
Is there another question from another judges?
Hi. Thank you to the Moon team. I agree with Ms. Koh. It's a very enjoyable presentation that it's very well executed, I think. I do have a question about the feature significance and the Sharpe value. Can you explain more about that, please? Thank you.
Okay, let me share my screen first. Okay. Can you see my screen? Okay.
Yeah.
Hi. Yeah. So this is an interesting tool to measure impact of the model on the output. So here, a couple of interesting observations that we could make is that first is that a lot of our newly engineered features have a lot of impact on the model performance. So that's good. Second one is that first, the highest impacted value is type underscore ADOE, which means that the type of alert at that day of week. So for example, in Sunday, what's the higher type of alert there is? And here, what the color means is that red means the value is impacting more to the true label, while the green, blue one means that it impacted more on the false direction. So here on type data, on the metadata, the one that denotes lower that impacted most on the true prediction is data is type of alert that corresponds to things like jam, if I remember correct. Yeah, type of jam, an accident, or weather or hazard. While the one that impacted the most to the blue or prediction being false is road closed or construction or miscellaneous. So that's secondly. And third one is that the second most impactful feature is the driver's count from the irregularities data by the day of week. So yeah, it makes sense that when a lot of drivers, if Waze wasn't the app reports that there's a lot of driver counts at a time at that particular location, then yeah, it is most likely being true that there is a jam or irregularities there. So that's I like to think.
Okay, thank you.
There's 2 minutes left. Is there any question from judges?
Actually I have one question from the team. So yeah, again, this is a good presentation. Very well, guys. So what my question is that from the feature, there is one feature called the driver counts, I think. Driver counts, right?
Yep.
Driver count. Yeah. How do you get that with for the test data?
For the test data. Yeah, I think Ade can answer this one.
Driver count. This is a driver count day of week, right?
Yeah, driver count by the day of week. So the way that we do it is that okay, Ade. Do you want to answer, Ade? Okay, so the way that we do it.
It's okay. Just continue.
Okay. Yeah. So the way that we do it is that we from the irregularities data, we make an ID for each data. The ID is that the location by the day of week. Day of week meaning is that whether the data is on Sunday, Thursday, or Wednesday. So what it really represent is that on that location, on that type of day, what are usually the how many is the driver's count for that day. So that's how we can join it also with the location and the day of week of the test data. So it is agnostic. It's agnostic according to the date or month of the data. It's only it only relates
So,
to where it happened at the day of the week.
Okay,
Okay,
just
the
want
time
to
is
add.
up.
Just
Thank
want
you.
to. Okay, thank you.
Okay, thank you for the Moon team
Thank you.
and the judges for the question. I wish you all the best for the result. Good luck, guys.
So what can we do? What can we do is that we can optimize existing roads. One of it. So how to optimize? One of the way is to accurately predict time and location of traffic jams, like the task given on Kaggle. And with accurate prediction, what can we do? We can give more early precautions to prevent traffic jam. One of it is to give early notice to citizens, be it on social media or on road signs, and we can also suggest alternative roads to take. So We can give the citizens suggestion, and we can also do prompt deployment of traffic polices before the traffic jam happens. And next, for the task, we are diving into the technical details.
Next is on data understanding. From that problem, we have three kind of data. The first is alert data, that's mean alert report from user. And the next is irregularity data, that's mean irregularity alert from the system. And the third is train data, that's mean training and that annotated manually. From that three kind of data, we found that something interesting part. The first is more than 1 million duplicate row in alert and irregularity that we must be handled. And the next, we found that 19% row as a type jam from all alert data. The other type is road close, accident, and weather hazard. That's not correlated with the jam, I think. Then not happen regularly. The next, we found that 17K row in train and test that have unidentified S2 token. That the token is found in the train and test, but not found in irregular data. The next is we have two ordinal feature with object data type that must be handled in data preparation. Okay, next, I think. That's our EDA result. The first in the top left, we found that is different jam distribution in train irregularity and alert. In the train, we have a peak hour in 17, but in the irregularity and alert, we have peak hour in 10. That's indicate some different time zone into data. The train following the Jakarta time zone and the irregularity and alert following UTC time zone. The next in the bottom distribution, we see that distribution of label is a little bit unbalanced for data jam and not jam. For data jam, we found the 66% is jam and 34% is not jam. The next in the top left, we see in different jam distribution in working day, Saturday, and Sunday. In the working day, we found that peak hour in 17, but in the Sunday and Saturday, we found peak hour between 14 and 17, I think. And the next, we found that similar jam distribution in working day from Monday until Friday. Is the peak hour in 17, I think because every people want to go in home from the work, and that's very correlated with jam happen. I think next.
All right, after we analyze and explore the data, we did some data preparations. The goal of this preparation is to create tabular data. Is to create tabular data where each row represents an aggregated feature for specific place and time. This is our flow, this is our steps, and we'll go more detail in the next slide. Next. All right, this first, we drop duplicates, and then we add 7 hours in our alert and irregularity data because of difference in time zone. And then we filter non-jam data based on the alert type, because we found that most of train data which relates to other type of alerts most likely labeled false. It means that other type of report isn't affecting the jam traffic. And then we map ordinal type feature. For example, this we convert it to an ordered numerical value, and then we derive some features, some important features like day of week, is weekend, specific location, and then we replace the new or unidentified S2 token, because we found that although the token is not found in irregularity or alerts, it's possibly that the train is labeled true, the jam traffic happened. So we try to estimate it with the nearest token. And the last, we group alert and irregularity by this specific place and time feature and calculate the average. Next. All right. We have some models and our primary model is these two, LGBM and CatBoost. And our consideration is around training speed, memory usage, and then the robustness of the model. Right, next.
And next, we have time window based estimation. So it is a very baseline submission and it uses no machine learning. It just averages the congestion level from day -7 to day -10 of predicted days. So if we are trying to predict day 21st, we are going to extract data from day 14th to day 11th. So it uses linear time computation. So it means that it's very fast and takes close to zero memory. And the last, we are going to back these different models. So we are trying to combine the power of these different models. Hamdi.
All right. This is our workflow, general workflow in modeling. For our boosting algorithm, we prepare our inputs first from the base features from ID. We get the position, we get day of week, is weekend hour, and then from alert and irregularity that we have aggregated before, we try to take the previous, current, and next feature. So for example, if the train data is in hour 10 a.m., we will collect 9 a.m., 10, and 11 a.m. to the input of this model. And then with various model, we try to bagging majority vote, and we get a better result.
Next, for the evaluation, we use different kinds of evaluation methods for different kind of algorithm. So we use stratified k-fold for the gradient boosting models, and we use time series cross-validation for the time window method. And here's our classification report. We achieve macro average F1 score of 0.76. And to conclude, we achieve a performance of 67.8, and we place fourth on leaderboard, both in public and private leaderboards. And we see that the most important features are the number of reports in the particular location and time, and we see a general trend of different peaks in weekends and working days. So from all these processes, we can see that the performance of the model. So if we can see we can predict that much, and the government can and all the people there can work to work by identifying the traffic jams. We can, and if we can curb congestion by 60%, Bandung would have saved 22.4 billion rupiahs. Thank you very much for the time.
Okay, thank you to Team Stong for this presentation. Now it's time for question and answer session. For the judges, is there any question that you want to ask to this team?
There are a question from me for your team. If you are required to provide a recommendation from the result of your analysis to each city, what is your recommendation?
Yes, so one of the recommendation that we can give is we can give recommendation for the city to provide a way to socialize the prediction. So if the city has already implemented an algorithm to predict traffic jams, it can distribute the information from various sources. So we know that governments have a social media; they can use it to inform people. And if they also have a dynamic traffic signs like the traffic sign that use LED, they can use it to post information before traffic jam happens. And they can also deploy traffic police before the traffic jam happens in a certain location. I hope that answers the question.
Okay, thank you.
Okay, hi, Stong's team. Thank you so much for the presentation.
I have a question about can you explain a bit more on the feature engineering process that you made? Are there any new features that you developed, and which features the significance to the model? Can you explain a bit more about that, please? Thank you.
Yes, please let me share screen, and Hamdi will answer it.
Okay. All right. Okay. Okay. Mostly, the feature that we use is from the alert and the irregularity data, like jam level, driver count, user count, and etc. But if we talk about new features that I create is, for example, latitude and longitude. I get it from DST token, and then we derive some time features like day of week, hour, is weekend, and based on our analysis, this is quite important to learn the pattern. And then the other thing is we derive the difference of speed, and yeah, I think that's the important ones that affect the model performance.
And to add, we actually derived the features in order to feed the gradient boosting model by creating the previous, current, and next alert and irregularity features based on input hours. So if we are trying to predict for 10 a.m., we create the features. We create the features of 9 a.m. and 11 a.m. So we impute the features based on the alert and irregularity. Probably Hamdi can explain what the feature from alert and irregularity that is imputed.
All right. As I told before, the features is from the alert and irregularity. So there are already many features that we used from that. We just aggregated it, and we find the previous, current, and next value of that feature.
Yeah. Any significance metrics that you produce to explain how the model works and which features contributes more to the model?
I can share the screen. That's good.
Yes.
I think Mr. Hamdi can explain this.
All right. For the feature importance, we just use the apa ya? The method from the library. We
And
don't
from what
have more advanced
data with
to
get
Java,
just the first one is we try to aggregate.
Do you want to add something?
No. Sorry, is Hamdi's voice audible before?
Can you repeat that again, please?
Yeah,
Hamdi, can you repeat?
Okay. Basically, we use the method from the library we use. For example, this is we use LGBM. There is already the feature importance method that we just call. We didn't use any feature importance analysis like SHAP or another method.
Okay, thank you.
Thank you for the question.
Hello, Stong.
Hello.
I am interested with time window feature. time window teacher, how is it? I mean, like the performance of that teachers and what kind of statistic do you use with the time window there? Like,
Okay.
is it average, or is it percentile, or what statistic do you use?
Okay. I'm going to share the screen again. So for the time window based estimation, we average. So we get the average of the congestion label, like 1 or 0s, from day -7 to day -10 of the predicted day. So after we get the average, we get a number between 0 and 1, a continuous number, and from that number we determine the we determine whether it is true or false, not by taking 0.5 as the threshold, but we sought to take the ratio between true and false in the train data. So the ratio between true and false in the train data is not 0.5, it's a 0.6 or something. So if it is greater than that ratio, we decided as true, and if not, it is false. So another interesting thing that we got from this feature is that it is very, very light. It is very very efficient, but it performs pretty well. So it's not below 0.6. It's even 0.62 something. And on the private leaderboard, it got to 0.63. So it's not very different from a baseline submission created by complex models like gradient boosting. And from that, we can conclude that for prediction that needs very, very little time and memory, we can actually use heuristics in order to compute the prediction.
Okay, thank you.
Thank you.
Okay, the time is up. Thank you for the judges for the question. Also, thank you for Team Stong for the great presentation. I wish you all the best for the result. Good luck, guys.
data that they collected, GDS wanted to create a machine learning model that could predict the traffic jam happening in the future, at least at the 1 week in the future. So the goal is with this model, GDS hopes to understand the traffic jam behavior of West Java so that they could prepare and react properly to the potential occurrence of congestions. So next, data understanding. So to help us with to tackle this issue, Java Digital Service provided us with 4 important data collected through the Waze app. The first one is alerts data. It consists of alerts level data submitted by the users. It has many important information such as the area reported, timestamp, reliability, confidence, and etc. And the next one is irregularities data. It consists of irregularities level data automatically collected by the apps. So the app recorded every occurrence of a vehicle slowing down irregularly or abruptly. And the next one is training data, which consists of S2 token 15, date and hour, and also the label. And finally, the test data, which consists of S2 token 15, date, hour, but without label for the submission purpose. So next will be Faisal.
So chart, we want to see the occurrence of each city in the training set, as well as the proportion of true to false labels. As we got 5 cities, produce the most data points compared to other cities. We can also see that the cities has tendency to have more true labels rather than false. And in addition, cities have a different proportion of true to false labels, such as Bekasi, which we can see has more true labels proportion than false labels compared to Bandung. Next. Okay, so next we produces 2 heat maps. On the first heat map, we wanted to see the distribution of true labels on the train data set for each city, grouped by the hour of the day. As we can see, most of the data points are generated in a specific time frames in the rush hour. As we can see that more data points are generated between 3 p.m. to 8 p.m. And moreover, we can also see that each city has a different characteristic of alert generating time. And in hours, the data points are very sparse. For example, from 0 a.m. to 6 a.m., which is why we decided to group the hour together to make data less sparse. And the second heat map shows the proportion of true label distribution of true labels from all the labels for each city by the hour of the day. Next. Okay, now for the heat map, we did the same thing, but we decided to group the data by the day of week, with 0 being Monday and 6 being Sunday, and the hour of the day. And we can see that on weekends, the data producing hours start to weekdays, which starts at 4 p.m. And also on the second hit, we can see the proportion of true labels for each day of week grouped by the hour. After we investigate further on alert types, some subtypes are not possible to happen in Indonesia, such as hazard weather heavy snow or hazard onward ice. So we assume that the most predictable and logical alert type that has a correlation with high congestion is jam type of alert. So we decided to filter only jam type of alerts before doing feature engineering. Next. Okay, as we can see that jam alert correlates well with the true label distribution that we see earlier. So we think that this supports our hypothesis from the previous slide that only jam alerts has a high correlation with true label. Okay, next. Okay, so now on this slide, I would like to explain the steps that we use in processing our data. So on the first step, the step that I call pre-processing is we clean the data. So what we did is first we separate the date, hour, and S2 token 15 from the ID column. And then we also format the date so that we have a date time type of column. And then we also adjust the time in train and test data with a GMT+7. And the next step, the first feature engineering, is we add the grouping variables. So we group the day of week by weekend or non-weekend. We also group hour with 4 types, which is rush hour, morning commute, afternoon, and late night. And we also add CD name to train and test data by looking up the S2 token 15 to the alerts and irregularities. So we created a lookup table from these 2 data sets, alerts and irregularities, and then we merge both of those tables. And then the next step, we aggregate the alert and the irregulars data. We aggregate the alert by grouping the S2 token 15, this weekend, and our grouping that we have created from the previous step. We decided to group by weekend and hour grouping because S2 token 15 data are very sparse. And if we group the weekend and hour together, we can have more data for each S2 token. So aggregation in alert is done by counting the occurrence of alerts for each S2 token, each weekend and hour grouping, and also averaging other variables such as report reliability, confidence, and etc. And we also done the same thing for the irregularities data. We simple count the irregularities and adding other variables such as speed difference, alert count, and etc. And then the next step, we merge the train and test to the aggregation we have done on the previous step. And then we also fill in missing value by redo the previous step, but with a higher level of S2 token. We do this up to the 12th level. And if there is still missing value after we merge with the 12th level of S2 token, we decided to fill the blank value with 0. And then after that, we train the model with the data that we have prepared. And then we also perform random search to find the best hyperparameter for our model. And then finally, we evaluate our model result.
Okay, so the next up is we also want to add some like features. So first of all, we added alert 70 feature and also irregularity 70 feature because we have this idea that maybe alerts or irregularities that happen the most recent could have a bigger impact. And also we added the interactions between alerts and irregularities because we also have the idea that maybe if alerts and irregularities happen at the same time, then it is very likely to be congested. So this is the correlations table, and as you can see, the labels actually, there is no single value that has very high correlation with the labels. So maybe the model interacts in a way that the variable interacts in a way that it gives some impact to the label. So, okay, so for the modeling, we use CatBoost from the Yandex open source ML because it works wonderfully for the classification problem and is very robust to overfitting. And for the random search, we use it instead of grid search because it is also very robust to overfitting, and we want to pick some hyperparameter tuning hyperparameter method that is less computationally expensive. And this is the hyperparameter tuning. So we decided to tweak the depth, learning rate, iterations, L2 leaf regulation, and random strength because we believe that these 5 parameters could have a huge impact on our model. And for the evaluation, we get 0.8 AUC score and 0.86 precision recall score. For the confusion matrix, our model is very good at distinguishing false negative, but is false a bit short in distinguishing false positive. So overall, we achieve F1 score of 0.85.
So for the evaluation, we plot the feature importance of our model. We can see that alerts has the highest feature importance, which proves our thesis that gem types of alert correlates well to the true label on the training data set.
Okay, the time is up.
Okay.
Thank you for the team Bandarmology for this presentation. Now it's time for question and answer session for the judges. Is there any question that you want to ask to this team?
Yeah, I have question. Thank you so much, Bandarmology, for the presentation. I'm wondering why do you use correlation to check the importance of the features? Can you explain that to me?
Okay, so maybe I should share the screen.
Hmm.
Mm. Is my screen okay?
Yeah.
So we decided we want to see that if there are features that has a high correlation with other features. So if there's a high correlation, that means that one of the two features are not needed. But we found that even if we remove those highly correlated features, it reduces our F1 score. So this is the best set of features that we can create for we have created for our model. So, and we also want to check if there's one features that could explain the labels. So if there's one feature that can explain the target well, we can use that features and hope that it can generalize well. Yeah. Maybe Ada, you have something to add?
Yeah, and also we try to use the correlations because it is just an as an initial for as an initial analysis for the future importance analysis, because we at the end of the day we also use feature importance from the cat boost, right? So this one is just like a support, I think.
Okay. 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 Okay, that's all from me. Maybe the other judges have question.
I have a question for your team. What is the ranks of learning rate value that you tune in your model? And how about the importance of the learning rate in the cat boost classifier?
Okay, wait a minute. Okay, so as far as we know, the learning rate does not create a huge impact on our model, but it helps on the speed at which the model get the most optimized result. Yeah, so the learning rate is only helps in speeding up the training process. Yeah, so I don't think the learning rate has a big impact on the.
Hi, Bandarmologi team. I assume that you guys are a trader. Okay, but anyway, thank you for the presentation. Very interesting. Can you show me the slides where you show the feature significance, feature importance?
Feature importance. Okay.
And yeah, can you explain how you interpret this this slide?
Okay, so we use the feature importance the CatBoost library. So this feature importance algorithm determines the highest ranking features. So all the feature importance adds up to 100. So alerts, for example, ranks first because it generates the highest value change when this feature value is changed. So what I mean is that alerts, change of value in alerts creates a huge impact on the model. Yeah, so this feature importance does not calculate the information gain from each feature, but it just ranks the importance of each feature on model. Yeah, so okay, yeah, so I mean that alerts, change of value in alerts basically creates the most impact on our model compared to the other features. Yeah, so maybe that's the answer.
Just to add a bit, also we want to use the feature importance to check our hypothesis, right? Because as we can see, alerts as 2015 and irregularities, they have like the top 3 rank, right? And it proves that our hypothesis that the number of alerts happening in certain area or the number of irregularities happening in certain area have a huge impact on whether the label is true or false, right? So yeah, so based on whether there are many alerts or not, many irregularities or not, and also where the place happening, which is represented by the S 2015.
Isn't the value that you're predicting are inside the alerts? I mean that you're predicting the true or false in terms of congestion, right? Was it not inside the alerts parameter?
Sorry, it's in the label, right?
Okay.
Alerts is the total count of the alerts happening in certain area at certain time. So we use the S2 token, S2 token 15, then our grouping and also the is weekend. So we aggregate the alerts by that grouping, where it's happening, whether it's weekend or what time is it, lunch or last hour, and then we just count the total alerts. Yeah.
I see, noted. Okay, thank you.
We have 1 minute left. Is there any question from the judges? No? Okay. Thank you to the judges for the question and Team Bandarmology for the presentation. I wish you all the best for the result. Good luck, guys.
Thank you.
Hello data people, welcome back to Data National Hackathon. Now, it's time for 10 team who will be present their ideas. Please welcome to Tugas Met Statmana. Hello.
Hello.
Okay, here come the last single fighter. Say hello to Maxwell Thompson. Tugas Met Statmana, please present your ideas. Good luck.
Okay. So good afternoon, everyone. Good afternoon, all the judges. So I'm Maxwell Thompson from Tugas Met Statmana. Okay, so next. Yeah, this is the outline of today's presentation. There is business understanding, data understanding and preparation, modeling and conclusion. Next. Okay, so for the business understanding, traffic jam has been an issue for West Java, especially in the big city we know like Bandung, Bogor, Puncak, etc. And it's one of the problems that must be resolved by the government and the society. So here, Jabar Digital Service, as one of the government and public service, has collected 7.5 million data from West application to be analyzed, and the solution will be sent to the local government as the stakeholder to make policies, regulation, or even decision making. So here is the problem statement. Given the West data information from Jabar Digital Service start from September 2020 to November 2020, can we predict the irregularities phenomenon or high jump reports that occur around the last week of November 2020? Okay, next. Okay, so we start from the data understanding. This is a quick overview of the 4 datasets that were given. But here I'm only using the training dataset, the data train dataset, and alert dataset to predict the data test data. Okay, next. Okay, so after I split the IDS feature from the data train into S2 token, date and hour, the S2 token is converted into latitude and longitude by using the S2 cell library. And for the picture below, we can see if we cluster it into 4 clusters using the k-means, the blue one, the furthest one, we can clearly know that it is Bandung. And for the purple one, it is Bekasi. And for the yellow or somehow brown, it is Depok. And for the red one, it is Bogor. So next. Okay, so here we plot the 4 cities that we have clustered before against the irregularities label. And here is the irregularities rate that happened for each city. And here we can say that Bekasi got the highest irregularities rate among the 4 cities. Next. Okay, so this is the flow diagram that what we are going to do with the data. So we start with the left one, the original train data, 71,000 data. So the idea here is quite simple. We want to split the data into 2 data sets. The first data set contains the alert information, and the second data set doesn't contain the alert information. So pay attention to the bottom side. Instead of using the 31,000 data that can be got by subtract the 40,000 from the 71,000, here I use the whole training data, the 71,000, to predict the 10,000 test data. Because we know as we use more data, the variance of error will be reduced, and we will better generalize the model. And later, the output of these 2 models will be combined together as the final output. Thank you. Next, Okay, so the idea is we want to merge the alert and training data, also the test data. But how could we do that? As we know before, the train data contain the S2 token and the date. The alert data also contain the S2 token and the date in the PubMe list that we have been converted to the local time. So here the idea is I create an additional column named the lookup one. So the formula for lookup one for the train data is the aggregation of S2 token, date, and hour. And for the test data, lookup one is the aggregation of S2 token, hour, and day week. Day week is the number of days in 1 week. So for the example in here, the lookup one in this trend data and the lookup one in this alert data is exactly the same. So we could assume that these two data come from the same observation. Then we merge the data and we apply this method to all of the trend and test data. Next. Okay, so this is the some other step of pre-processing that I've done. For the first data set, the trend data, I cluster the latitude and longitude into 4 clusters, and then I mark the days as 1 for the weekend and 0 for the weekday. Also, I discretize the hour using the decision tree classifier into 8 unique values. For the second data set, it was almost the same, except I categorized the MACFAR into 4 levels for cardinal direction. Okay, so the final feature that we have for the first data set, there is a cluster that has been one-hot encoded, the is weekend feature, and hour. And for the second data set, we got cluster, type is weekend, hour, MACFAR, route type, reliability, report rating, and confidence. Next. Okay, so before we move to the modeling section, this is the target class proportion of 2 data sets. As we can see in the plot, both data sets have imbalanced label. Therefore, we will it will affect the metric and the method we will use later. Okay, next. Okay, so for the modeling here, the metric that I chose is F1 score. That is the 1/n times the summation of I from 0 to n of the F1 score. Or basically, it is the average of each label F1 score. So I use this evaluation metric due to the previous slide, we know that the data is imbalanced. Okay, so for the first data set here, the trend only data set, there is the original one and the one I resample with smooth technique. So we can see the overall score for smooth technique is higher than the original one, especially the XGBoost and random forest. Okay, next. And for the second data set, although I have resampled it with smooth technique, but for the overall, the original data set was better than the one resample. Therefore, for the second data set, I will use the original data. And here we can see XGBoost logistic regression and random forest is pretty good for classifying. But when I test it to the public leaderboard in Kaggle, the random forest outperformed the other classifier. Then I decided to use the random forest classifier. And I tuned the hyperparameter as follows: the max depth, the mean sample split, and the mean sample width. And also I set the class weight to balance. Next. Okay, so this is the final model with the following parameter. You can see as follows. The first data applied the smooth technique, and the second data doesn't apply the smooth technique. And the result at the public leaderboard, it is 0.66. And in the private leaderboard, it improved to 0.67634. So we can say that the model that we use doesn't overfit and can perform really well in the unseen data. Next. Okay, so for the conclusion here, trend data and the alert data and also the irregularities data can be connected together using the time and the F2 token that I have shown before in the flow diagram. And also here, among the 4 big cities, Depok, Bandung, Bekasi, and Bogor, Bekasi actually has the highest irregularities phenomenon rate during the 3 weeks time period. And also, smooth technique can somehow help to improve the result of the model. And the last one, random forest classifier with the tuned hyperparameter can give a good result both in the public and private leaderboard. Okay, so that's thank you. That's all for the presentation.
Okay, thank you to Tugas Med Statmana for this presentation. Now it's time for Q&A session. For the judges, is there any question that you want to ask to this group?
Sorry, I think I might have missed how did you append the test data and the alert data? How did you predict the output when you append them?
Okay, can the committee share the screen again to the flow diagram?
I think that's on slide 7. Yeah.
Okay, thank you.
Previous one.
This one, okay. So there is a lookup one column. So I make a copy of the alert. There is 2 copy. One, the copy is for the train data. I make the lookup one with the S2 token, date and hour. And the second alert data, the lookup one is for the test data. It has the S2 token, hour and day, week. So we could just somehow filter the alert data by the lookup one column. If it is the same, we could assume that it is the same observation. Then we combine it. Does that answer the question?
Oh, I see what you're doing. Okay, so what happens if the alert there is 2 values for the same token, the same hour, and the same day of the week?
Yeah, honestly, there is a lot of like a same value, the same lookup value, but most of them, the value of the feature is almost the same. Like the max for the alert, the max var is the same mostly. I'm talking about mostly. The max var is the same. The rod type is the same. The difference is slightly very small at the reliability and report rating. So I just pick up the top one, just simple, like a simple random sampling. I take the top one of the alert.
I see. Okay. All right. Thanks.
Check. I have a question for your team, Tugas Mestat. The reason why you didn't tunning the n estimator hyperparameter, and even though n estimator is an important hyperparameter in random forest.
Okay, so honestly, I got a like very low computer specification. I only got a netbook with 2 GB RAM, so it couldn't like run on the very heavy computational process. So I chose from the very light one, the 100 as an estimator. But I on the notebook, I also try to use the other n estimator like 150, 500, or even I try 1000, but it takes really long time. So I use the 100 n estimator for the efficient of the computational process.
Okay, thank you.
Hi team, thank you so much for the presentation. Can you guys give a conclusion based on your modeling, but more on a business understanding perspective? Because on the conclusion page, I see that's a way more technical. I mean, what can you give a conclusion to the governor, for example, or to the JDS team?
Okay, thank you. So for the conclusion, it has been mentioned that Bekasi has during the 3 weeks period, Bekasi has the highest irregularity rate. So here maybe for the Bekasi local government, mungkin Pemkot Bekasi, it has the job to do the like making some policies or regulation that could help to resolve the traffic jam problem. So here, I'm somehow thinking of maybe, I'm talking about maybe the government can create an application, the application that can predict the traffic jam. For the example, a person who lives in Bekasi, he wants to travel to Bandung, for the example. Tomorrow he wants to travel to Bandung. So this application can give him the best route, give him the best recommendation and suggestion. So he wouldn't stuck or trapped in the traffic jam and can reach the place, reach the destination with the optimal time. So I'm thinking if everyone in Bekasi, for the example, use the application or use this method, so the traffic jam problem will of course decrease. Okay. And so this is not only Bekasi and maybe the other area of West Java like the Bandung or the Depok. Depok is very crowded in Margonda. Yes, of course, we all of us know, and also the Bekasi, Bogor, Depok, and Bandung, the four main big cities.
Okay, thank you.
Okay. Hello.
Hello.
Tugas might start. This is a good presentation. I want to know more about the F1 macro here. What is the F1 macro? What is the why the Smote on XGBoost it's better than the original? I mean, what happened with the original? Why the XGBoost is not kicking than the logistic regression?
So
you have
is for the second data set or the first one?
The slide 11.
I don't get
the first data set, yeah.
Okay. So this is just I'm doing a lot of trial and error, but this is my guess. Like the data for the first data set, it is not that complex. I mean, only got 3 features. So by using the random forest, it is enough to not overfit the data and can give a better result.
Okay, got it. And my other question is, why do you need to do this the clustering in the beginning? Yeah.
So this is due to the same reason again, my low computational process. I couldn't like encoding every the SO token or make a lot of big sparse matrix. So I think of cluster it into 4 main clusters. So it will reduce the computational process and also make it more efficient. This is what I think.
Okay, got it. Yeah, maybe for the future reference, you can do the computational the computational thing in cloud. I think. I mean, like there are some service that you can use if your local is not enough. Yeah, just suggestion.
Thanks.
Okay, cool. Thank you.
Thank you.
Okay. Thank you to the judges for the question and Tugas Met Statmana for the presentation. I wish you all the best for the result. Good luck, Maxwell.
Thank you.
people, welcome back to Data National Hackathon. Now, it's time for 11 team who will be present their ideas. Please welcome to Team Bloom Discuss. Hello guys.
Hi.
Hi.
Okay.
Hi. Hello.
Okay, there are 3 amazing participants in this team, including Reza, M. Insan Aprilian, and Devianti Aryani. To Team Bloom Discuss, please present your ideas. Good luck.
Thank you. So, hi everyone. Thank you for the opportunity and for joining with us today. Gratefully, I got a chance to be a speaker here, and that's because I have a wonderful team to work with. Next. So let me introduce us a bit. I'm Devi, and there are 2 gentlemen here, Reza on the left and Insan on the right. Next. So, as some of us may have experienced it for a quite long time now, people in big crowded cities of Indonesia have been wondering what it feels like to live without wasting too much time being on the road, and been expecting to have a system that can tell us about what traffic problem that we might face today or even 3 days from now. And if we think it through, what we expected may be possible to come true, and because there are recurring traffic problems in certain areas and time, and there are abundant data records from traffic app, and that we can utilize for further research. And so our goal here are to use the data to predict traffic irregularities on certain space and time, and hopefully the result will be implemented on real life. Next. Okay, so for this project, we got alert, irregularities, and train test dataset. From alert, we get information about route type, report quality, type of alert, and from irregularities, we get information about irregularities magnitude, quality, and speed details. And they all have common features, which are location. Here we are using S2 token, which is a unit of rectangular areas on maps, and time, which are date and hour. Next. So while working on the project, we faced some challenges along the way. The first one, common IDs from data source doesn't cover all train test data. On the slide, we also provide the sample of ID structure, S2 token underscore date underscore hour. And here's the thing. Sorry, there's a point. Some of data from train test happens in the future. By that, it means they don't have alert and irregularities data at that time range. So what we did here, we generated more general information from existing ID to maximize merging process. For S2 token, we try to find the nearest S2 token from alert and irregularities data so that we get predicted city, street, and road type for our train test dataset. And we also derive weekend, weekday, and week of month, payday period from the 80% of the data have low confidence and reliability value, which indicates low quality report irregularity, and more for irregularity, more than 60% of the data have less than 5 alerts count value, which indicates low number of user in the irregularity area. And what we did, we created constraint to improve our data quality. And for alert, we only take reliability more than 5 and confidence more than 0 into account. And for irregularity, we rule out alert count less than 6. And next Reza will explain further about data insight.
Okay, thank you, Devi. Now I will continue. Once the data already merged, we can now know the data insights from the train data that already labeled true or false. First, we will deep dive into the true one. So the first one, we know that on the weekend, most of the irregularity happened on the lunchtime till the afternoon, which indicates like a weekend hangout. On the weekday, the irregularity mostly happened on the evening rush hour, which happened around 15 to 19 o'clock. And the top cities for the irregularity that might happen is actually Bandung, Bekasi, and Depok respectively. And from the alert data, we know that most of the hazard and most of the irregularity happened because of the pothole. And we know that because we divided by the payday period or not, irregularity mostly happen, more likely to happen in the payday period. On the false train data, The interesting thing is actually on the continuous variable, it has a basically lower average values from the true trained data, but not that significantly different. And also we have an imbalanced total number of false data sets compared to true, so 2 to 1 for the ratio. And also irregularities happen less on a non-payday period. We go to the modeling, and Insan may take over.
Thank you, Reza. So I will take a part on the modeling side. From the problem on the data set itself, we know that mostly our variable that we use to do the training is contain many missing values, especially for the usable predictors that could have drive the good result of the model. Like for example, the irregularity part and also the error part. And the second one, we have from the analysis, the predictive power of individual of our variable is not sufficient to have the linearity or predictive power to could have the pattern to predict the result or the label data. And the third one, as we also do the analysis, we know mostly of our set contain many correlations so the irregular part. So to tackle this, we tried to discuss and decided to use the XGBoost because the XGBoost quite have many benefits in terms of getting off the mission to get the best model or best performance. Like for example, XGBoost could robust to the missing value and also correlation because we preferable to use the interaction between them. And next, so how we implement this modeling or how the workflow of to generate the model. And this is, as you can see from the screen, the process in general is iterative process. We try to generate more and more aggregated variables to have the best score. And this is quite common in data science project. So in overall, I can say that the process itself is more general, but if you want to have specific explaining about this, we can move on later. And next, so from the model itself, from the evaluation on this resulted model, we have some suggestion to improve our model. The first one is doing the deeper variable engineering, generating more aggregated variable, and also getting better imputation and transformation strategy and doing the advanced parameter tuning. And also to understand the model better, I recommend to also adding the metric to explain the model, for example, like importance or shot. Next.
Okay, thank you, Insan, for the modeling part. Now I will continue again for from the data part. So what can we improve from the data part? So here, actually, we can get more accuracy by overlaying with more external data. First one, we can, if we have like an attraction data, like how many landmarks, how many mall, or how many station that we have in there, it can be an attraction, and then we can have a weather data, we can have a population data, and then we all can overlay with accessibility data, in this case, like a public transport data, and also a poverty. And the next one is, let's be honest, that it's nearly impossible for us to eliminate traffic at all. So like what can we do now is just reduce it and get a business value from it. So in here, we offer two solutions that we can give. The first one is for the governmental side, and the second one is for the business value side. For the governmental side, we can give like another system to prevent or reduce congestion based on our prediction. The second one is the public transportation planning. So it will be better for it will decrease the vehicle and then tighten the building permit regulation and increase taxes on the highly congested area and higher parking price on the center of attraction. And for the business value, we can create a bazaar or event to the less congested area on the payday period, let's say to diversify the traffic flow. And the second one that we want to focus is to regulate advertising billboard price based on the traffic density, time of day and area. So, I mean, if we are stuck on the traffic, what we really do, right? So we can see the billboard and how do we implement it? So in here, we have like a simple matrix. The x-axis will be the attraction index and the y-axis will be the traffic density index. In here, we can classify each place with their own value. The higher the value, we can get a higher price. In the conclusion, from the prediction, we use XGBoost with the accuracy around 67%, and we can do a better improvement from the model by using a deeper model and variable engineering, and also additional external data. Okay.
Okay. Thank you for Bloom Discuss group for this presentation. Now it's time for Q&A session to the judges. Is there any question that you want to ask to this team?
Yeah. Hello. Hello, Bloom Discuss.
Yeah. Hello.
Hello.
Yeah, this is interesting presentation. Thank you so much for the presentation and the insight. There are so many insights that you gave us. Can you maybe elaborate more on the slide 14?
Okay. Let me share my screen again.
Yeah.
This one, eh?
Yeah. Yeah.
Okay. Yeah. Okay, so I will explain more about this. So
Yeah.
sorry because the time constraint. I have to rush.
Yeah, I know. Yeah.
So yeah, I will explain it again. So for the x-axis is the attraction index, and the y-axis is the traffic density index. Basically, the attraction index is something that we can get from the external data that we have that I have already mentioned before, which is like this part. Like an attraction, let's say if there's like how many malls in the certain area, like certain S2 token, let's say, and then like how many is the population in there, and is it like accessible for people to go there? Is there like any like a Transjakarta or maybe like a train station, things like that? Where there will be, I think it will be considered for the traffic. And poverty, I think it's like a buying power of the population in there. If it's like has a high buying power, it will be maybe like have a higher value on the index, while the traffic index is actually based on the data that we've already got, let's say like in the alert and irregularity data. So we can know like how congested the area is based on like some values that we already get on the alert and the irregularity data. And yeah, in here we just divide it by 4 metrics, so it will be easier for us to understand.
So you calculate, you already calculate the attraction index here, right?
No, this one is actually only for illustration because we didn't have enough time for it. But actually, we've already did this kind of analysis in the other project.
Okay.
In my company actually, but yeah, this is actually one of the analysis that we could give.
Okay, got it. Yeah, I thought you already get the data from. I thought you already get the calculation from the data that we have. No, okay, okay. But this is one interesting insight. Okay, that's all from me. Maybe from GDS or Mas Hendian, or maybe from the other judges. Yeah, from Alvina maybe.
Hi, thank you so much, team. Very interesting presentation. Can you guys explain more on the feature engineering side? What new features have you created? What works, what doesn't, and how does it affect your models? Yeah, tell me the process of your feature engineering. Thank you.
Okay, for the feature engineering, I think I will explain a bit, that maybe Insan will add more for this. Let me share again for the presentation. So for the feature engineering, yeah, I think we are facing the same problems with all other contestants in here. So the first one will be like we cannot really merge the data. Like if we plainly use the common ID token, so we have to use a more general information that we can extract, like the city, predicted city, and then weekday or weekend, week of month, daily period, things like that, and we use that as a common feature, and then we will merge it. It will be like a key for the alert, irregularity, and also the train and test. So that's the first thing. And then the second one is we kind of realized that there are a lot of data and not all of them is actually have a good quality. And in here, we kind of eliminate the data that we think doesn't have a good quality. And these are the constraints that we use. So, but actually we eliminate this after we use the data, like all of the data for predicting the city and the street and everything. So we get the full data first and then to predict the city and the street. And then for the other things like an alert counts or like irregularity magnitude, things like that, we already eliminate the low quality data. I think for the modeling part, Insan may add more about this.
Yeah, maybe from the main source like the irregularity or alerts, when we try to merge this data set into our training and test, we try to make it less general, because at the raw data we have like the specific numbers of hour and also day. So in the end of the day, to get more penetration of data, so we have reduced the missing value from the data set. We try to make it more less complex. Like for example, we try to make the group by in daytime, like group by morning, afternoon, evening, or midnight. And also after that, we try to assess, as we know that the constraint will be, there is some of the similar value between the ST2 token. This is quite common because we try to get more penetration of these alerts and irregularity data into our training and data set. So I think the most problem there will be the correlation, and it appear as you can see on the screen.
Okay, thank you.
There's 2 minutes left.
Okay, from me. I have a question for your team. Please explain to me what is the most important feature of your model? Maybe top 3 feature important.
Okay. Okay. Wait. Okay. Is the screen already shared?
Yes.
Okay. Yeah. So yeah, I'll explain about this a bit. So yeah, this is the feature importance that we get from some of our features that we use on the modeling. So I think it's somehow quite similar with the previous team also. The first one is the alert type, but we did a weight of evidence on it, and then the irregularity count, and then the daytime. I think that's the top 3, and then the rest is following, as you can see here.
Okay, thank you.
Okay, that's it. Thank you to the judges for the question and Team Bloom discuss for the presentation. I wish you all the best for the result. Good luck, guys.
Thank you.
Thank you.
Welcome back to Data National Hackathon. Now, it's time for 12 team who will be present their ideas. Please welcome to Doa Orang Tua. Hi guys. Okay, there are 3 amazing participants in this team, including Fatih Abdul Muhyi, Fatimah Azahra, and Audi Aprilian. To tim Doa Orang Tua, please present your ideas. Good luck.
Okay, we'll present to you about our presentation. Me as the leader, Fatih, and our member, Audi and Fatimah Zahra. We will start from the business understanding. Have you ever sat in traffic, wondering how much time you could have saved if you weren't stuck in gridlock? What about if you had taken the left turn at the junction instead of continuing the highway, only for a never-ending queue of vehicles to greet you? Traffic congestion costs people valuable time, fuel, and frustration every single day. At the same time, they act as a major obstacle to money industry by reducing their efficiency, undermining their reputation, and causing great economic loss, compounded by environmental damage. And it disrupts the amount of congestion impact government who need to keep traffic flowing for the movement of goods, reducing pollution in certain areas, and for the safety of those on the road. Traffic congestion usually occurs by 2 reasons. About half of traffic slowdowns are caused by temporary traffic flow disruptions. These are the unwelcome surprises that take over part of the roadway, such as accident blocking a lane, a construction zone causing a bottleneck, or inclement weather conditions that affect all drivers. These are the slowdowns that you typically can anticipate. The other half of slowdowns are caused by recurring conditions. Many drivers experience this delay multiple times a week. They are more predictable as they occur whenever too many vehicles enter the road, such as during specific time of day, in the rush hour, which is likely on the way to work, after work, or weekends. Even though we know when they are likely to occur, many of us can avoid getting stuck in this delay. It's simply because our schedules are too similar to those of the other drivers on the road. Still, there are strategies to reduce the likelihood of being caught in a jam. For example, it is a good idea to learn alternative routes for daily travel through GPS, perhaps, or many commuters swear by the free app ways, which offer real-time traffic and route information. You can use it to reroute your trip, search slowdown or traffic jam over while you're driving. In September, the Asian Development Bank (ADB) published a study called in the 2019 update of the Asian Development Outlook, informed that Bandung ranked on the 14th position as city with worst traffic in Asia, compared to Jakarta that holds in the 7th place. The result of this prediction will be used and directed as input and consideration for GDS and local government in Java for making policy related to this traffic issue, such as changing the parameter of traffic light nearby, using variable message sign, sending information to the driver by means of radio broadcast or mobile app, traffic counter, etc. In other words, accurate real-time prediction throughout prediction of traffic jam is actually mean of the intelligent transportation system operation optimization. So you can always avoid traffic, but with accurate traffic prediction, we can make smarter choices that can save you money, time, and interest of road safety. Highly accurate traffic information also helps government by supporting the development of smart and sustainable systems to reduce asphalt pollution level. So our problem formulation is how to predict high jam report in certain sector at certain date and certain hours of activity in West Java, such as Bandung, Bogor, and Bekasi. We will start from data understanding. We start with the source of our data to build the model. There are 3 sources. It's the data train, alert, and irregularities. Data train is the training annotation. It contains something that we want to predict. The high jam report and alert data is the report from the user, and irregularity comes from the system. From the first table, we will need date, time, and also SPCL. From our data, we will need city, longitude, and altitude. From irregularities, we will take city and highway status. In the modeling, we actually adding another variable one by one, but these are the best options we got so far. Here is our data pre-processing. From training data set, we extract some features from that, such as day of week, weekend, or weekday, days of month, plus hour status, etc. Then we combine with the aggregated value from our data and irregularities data. We will only use variable that the value doesn't change over time, statics, because it won't be available when we need it. After the data measured, we were doing some data cleansing until our data is ready for the modeling. And after we clean the data, we were doing some exploration to decide what to do next. For some highlight, first, we found that our data is imbalance with the ratio between high jump report and non-high jump report is 2 and 1. We need to do modeling very carefully, and giving some treatment, we decided to change the threshold of the probability because we don't want to manipulate our data too much. The next highlight, we explore the form of the relationship between each our predictor and the high jump report, and we found there are nonlinear relationships such as between hours and high jump report. Our action is to do binding for the variable that has non-linear relationship with the label, so our model can learn more. And when we found out that some variable visually there is no significant difference, it is expected that the difference will be obtained from the interaction between another variable. So we will still use it in the modeling. We also want to show some highlight of our preprocessing. Here is our list of variables that we use in the modeling. And for the city variable, we made dummy variable. Also notice that there are some locations that placed in the border. For example, this S2 cell is located in border between Parung and Gunung Putri. So we'll encode giving value 1 to dummy in the border to dummy for Parung and Gunung Putri. Many other locations and appear to be like this. And after this, we will continue in the modeling process. Modeling process contain pipeline, machine learning model, and evaluation. First, the pipeline. There are still some variables that needed to transform to certain form, so our model can achieve the optimal result. For some categorical variable, we use one-hot encoding. This transforms the categorical variable into numerical value. There is also a method called binary encoding. This method can be seen as the alternate to one-hot encoding when there are too many categories. So many categories will make us generate many dummy, and it leads to overfitting. Binary encoding can reduce the number of features generated. We also use binding for our numerical variable, like we mentioned before in the exploration. This method is used to capture nonlinear relationship in the modeling, so our model can learn more. This feature engineering scenario might only suited to a certain model. This scenario is suited for model that we will use in which is linear model. Different type of model, such as ensemble, might require another scenario. Here is our model. We will try some model that included in the linear model, such as logistic regression, read, and SGD classifier. We use linear model for some reason. First, linear model are able to extrapolate. In this case, we will need to predict high jump report for the last week of November in 2020, which is an extrapolation. Second, linear model usually have stable result compared to any other model, and it is easy to control overfitting and underfitting in the linear model. Third, linear model also has high interpretability compared to any other model. Next, we have to compare these three models. We were using stratified cross-validation. We need to compare our model that we mentioned before using this stratified cross-validation. Our consideration is the distribution of the data. We want to make sure that each set will have the same proportion of the high jump report. And then we will choose the model with the highest mean F1 score. This is the business insight of our model. The model we got is the model with the highest F1 score, which is, what is F1 score? It is the combination of exactness and completeness. We got F1 score 0.66, both in the test set and training set. What does it mean with exactness? From our result, we predict that there will be about 13,000 high jump report, but in reality, there will be only 9,500 only. We want our prediction result match as much as possible with the reality. Then, what does it mean by completeness? We want to detect high jump report as much as possible. Our final model is able to, let's say, there are 9,500, about 9,500 high jump report from that we can detect from about 11,000 high jump report. And then we also investigate what caused the high jump. By using our model, we found out that the cause of high jump is the most predictable one, like certain location, certain time, and highway, and also holiday. There are certain locations that affect high jump report, such as Cimahi, Parung, Tarumajaya, and Tambun Utara in certain time. also more likely to have high jam reports such as in the afternoon and office hours. Type of roads such as highway also affect the high jam report. We also found out that in the holiday, they are more likely to have high jam report. And this is only the top 8 factor that cause the high jump. There are still more than this, if you want to know. Yes. And the conclusion of our model is, after we are doing some experiment, we found out that our base model is SGD classifier. This model is able to achieve 0.66 mean F1 score in the local, and in the leaderboard is about 0.67. The capabilities in general, we can detect about 96 out of every 118 high jump, and for every 134 of our prediction that they are stated as high jump, there will be about
Okay, time's up.
high jump only. And the
Okay.
factor of high jump report must time, location, holiday, and highway. That's all from us. Thank you.
Okay, thank you to tim Doa Orang Tua for the presentation. Now it's time for Q&A session. To the judges, is there any question that you want to ask to this team?
Hi, I actually just have one simple question for the team. I think on slide 10, if you could bring back the slide. Slide 10, I think you mentioned that the relationship between hours and high jam report is non-linear. And then I think you showed the chart showing that it was all random across the 24 hours. I was wondering, how do you derive this chart? Do you just kind of normalize all the total count to 1, and then that's how you plot it?
Yes, we count the percentage of high jam in each hours. So in 7 o'clock until 8 o'clock, how many percent? And in 8 to 9 o'clock, how many percent? And so on. Like that.
Okay, so you normalize to 1, I guess,
Yes.
to a percentage, but that will disregard the number of counts, right? The number of absolute counts. So if there are more data point at maybe 10 a.m. versus more data point at 2 a.m., then if you normalize everything to percentage, then this chart does not fully represent the situation.
Yeah. Actually, we are also doing another chart that only contain that we don't do normalize. We were doing this in the 10th slide because we want to make an apple to apple comparison. That's our reason.
I see. Thank you. But that would actually that's not because I think during certain hours not that many people will report things. So this chart might have to relook a little bit. Yeah, that's all for me. Thank you.
Okay, thank you. There is another question from other judges.
Hello, Doa Orang Tua. I have a question for your team. If you are required to provide a recommendation from the result of your analysis, please give me a recommendation in each city.
In each city, there may be some different behavior about the high jump reports. For that problem, I think we should investigate more in each city, how is the behavior, and then take any decision that suited the most. For example, in the beginning, we suggest some potential solution like changing the parameter of the traffic light, using variable message sign, and etc. like one-way state regulation. I think we must choose the most suitable solution because in each city there might be different behavior.
Okay, hello, Fatih. I have a question in the slide 16. you have a business insight here, you said, and there is a exactness and then completeness. If you must choose between exactness and completeness in this case for this problem, which one will be your focus? Is it exactness or completeness, and why is it?
I think we will just sorry, my thing. I think it's about completeness because it will be so annoying that we predict that there will be no high jump report, but actually we will get stuck in the traffic light in the high jump. It will be so annoying for individually, for government, and for even for industry. So we think that completeness is more annoying than the exactness.
Okay, that's all from me. Thank you.
Hi, Mas Fatih. Thank you for the presentation. Do you also try to use other nonlinear models as well? And how's the model performing on your dataset? And why do you think that is?
Actually, we only so far we only use these three models. They are logistic, rich, and SED classifier. I think we don't have enough time to try another model. And actually, we also try some model like XGBoost and random forest, but those model we think that those model don't work properly, or actually we can optimize this model. We can only optimize the model we do. That is the SED classifier, logistic, and rich. We only try those three models. And
Okay.
Yeah.
Okay, thank you.
Okay, there's 3 minutes left. Is there any question that Judge want to ask to this team? No? Okay. Thank you to the judges and for the question, and to Team Doa Orang Tua for the presentation. I wish you all the best for the result. Good luck, guys.
Yeah, thank you.
People, welcome back to Data National Hackathon. Finally, it's time for the last team who will be present their ideas. Please welcome to Team Papa Hanif. Hello, guys.
Hello.
Hi. Okay, there are amazing participants in this team, including Amanda Pratama Putra, Hoirul Afifanto, and Ahmad Fauzi Bagus Firmansyah. To Team Papa Hanif, please present your ideas. Good luck, guys.
Thank you.
Thank you. Oke. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Judges, thank you for the opportunities. We are Papa Hanif team, consists of Amanda Pratama, Ahmad Fauzi, and me, Hoirul Abifanto. We'd like to present our solution for this Data National Hackathon. Next. In the first section, we'd like to talk about the business understanding. Next. We'll start from the background of the problem. From 2020 population census, West Java, with population of 48.27 million people, is the most populous province in Indonesia. It covers about 18% of Indonesia. Moreover, based on ADB report 2019, Bandung placed 40th among 278 Asian cities in terms of congestion. And people spend 20% more time during peak hours than off-peak hours. People density and congestion are highly correlated. Based on chain data, as the size of population grow 1%, the congestion level experienced by drivers will increase from 0.3 to 0.4%. So the traffic congestion is an enormous threat to economic prosperity and way of life in West Java. Therefore, an accurate prediction of high-level traffic is necessary. It can be useful input and consideration for the Jabar Digital Service and the local government to overcome the traffic congestion problem. Next. We have three objectives for this task. First one, we analyze waste data information from Jabar Digital Service to gain the insight of the data. Secondly, we make a model to predict high jam report on certain sector or area, dates, and hour of few cities in West Java. F1 score to make sure that our prediction has good performance. Okay, next. Next session is about data understanding. Next, we have four data sets consists of training data, alert, irregularities, and testing data. Training data is taken from 1st September till 3rd week of November 2020, has imbalance labels that must be handled in our solution. We also found that alerts and irregularities data have duplication problem, so we need to deduplicate the record. Testing data, which taken in last week of November, consists of 13.8 thousand records. Next. Okay. This slide presents the data distribution by hour. From our exploration, we found that hourly distribution of alerts and irregularities data have similar pattern with training data. But the most interesting part is of peak hour at 10 p.m. to 5 a.m. only have few records. This leads us to the assumption that off-peak hour has less jam report, or we can say lower. Training data is imputed with force label when there are no data in specific sectors or area at certain dates and hours. Finally, the imputed data is sampled with equal size for each label to handle the data imbalance problem. This treatment would produce about 94,000
Okay, I will handle this one. Next is about the weekly traffic by time of day. We present the insight about the weekly traffic by time of day. As soon as on this heat map, the 5 p.m. till 6 p.m. are the worst rush hour because many sectors had reported high traffic. This happened in all day. Moreover, on Saturday, the rush hour is earlier, starting from the 10 a.m. until 6 p.m. Next is about the insight about the monthly traffic by day of week from September to November 2020. Generally, most traffic congestion occur on Friday and Saturday. But look at the pattern. Before Friday, the average of traffic occurrence are similar than increasing on Friday and have peak on Saturday. After that, drop off on Sunday. In addition to that, the figures show that the traffic is relatively increased from September to November. It can be assumed that the relaxation of national social restriction gave influence to the situation. This one about the congestion occurrence by area. It can be shown that the Bandung is the city with the highest congestion report, with located mostly in all sectors. Meanwhile, Depok, the congestion only occurred in some specific places. Next one, the slide about the feature engineering that we use in the model with their own definition. All these features are generated by feature engineering process resulting through time, location, and the additional feature. Maybe a next slide. Next slide. About the machine learning model. Uh, Model that we use is a CatBoost. It is a machine learning algorithm that based on the gradient boosted decision tree. During the training, a set of decision tree are built consecutively. The first week learning is built and the loss metric is calculated, and the next tree is produced to reduce the loss. This process will be continued until the loss are minimized or meet the stopping criteria. Compared with other gradient boosting algorithms, CatBoost has several advantages, such as excellence facing heterogeneous, easy to use, work on small data size, and support the categorical variable. Next will be presented with my friend Amanda.
Okay, thank you, Oji. Next, related to the modeling strategy, we carried out the modeling scheme in two phases, namely the validation phase and the testing phase. In the validation phase, we split data using a holdout scheme by following this configuration. We decide to use holdout because we want to try to mimic the problem statement as close as possible. And the validation phase needs to be done first, so we are able to train the model with measurable performance. We can also obtain the optimal labeling threshold and the optimal hyperparameter configuration. Next, for the model evaluation, the first things that we check is ROC curve. And for the validation data, we got an ROC score for 0.65 and obtain an optimal probability threshold at 0.5121. By using this threshold, we then making the label prediction. And from the evaluation in the validation phase, it shows that the F1 score on the training data is 0.93 and 0.83 on the validation data. It means that our machine learning model has a good generalization and good performance on historical data and the unseen data. And next, on this slide, we want to show an interpretation of our model from the testing phase, because we believe that the model interpretation is very, very important. So we can show how it works and be responsible with the solution. The feature importance shows that S2 token 15 and hour are the most influenced features for the model. It means that the model can catch the pattern of traffic congestion and do the classification according to the location and time. In here, we also have a work hour as important features. It is more general than hour, so the model still can predict the data in some sector, even though there are no historical data at some hour before. On this slide, we also show an example of a labeling process performed by the model. Here is the prediction of traffic congestion at the sector in Bekasi at 19 o'clock. The model predicts 94% probability of congestion for this case, so it's labeled as true. And the next step, we evaluate the model in the testing phase by replicate the configuration from validation phase, and our score for the testing data is 0.72, the highest score on the leaderboard. Therefore, we are confident with our machine learning solution that already met the objective of this task. And this is for example, this is the visualization of our prediction for traffic congestion in Bandung and Depok. It's clear that the model already learned different patterns for each city, each day, and hour. And finally, for the conclusion, there are three key takeaways that we found. First is data understanding is an important step to finding the insight, values, and important variables. Secondly, pre-processing the data, including the imputation and feature engineering, played a key role to improve the model performance. And the third one is our machine learning solution has performed well and can predict the traffic congestion on the next week accurately. And finally, for the next step, hopefully we can deploy our machine learning solution to production so it can be implemented in the real case and help the local government to tackle this problem. We also want to adding more information from external data like a population density, landmark location, public holiday, weather, etc., to improve the model performance to give a better accuracy. I think that's all the presentation from our team. Papa Hanif, thank you for all your attention, and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Okay, thank you so much to Team Papa Hanif for this presentation. Now it's time for Q&A session. To the judges, is there any question that you want to ask to this team?
So thanks for the presentation. It was quite a well done presentation. I just have one question to ask on the data imputation and sampling on slide 8. Can I ask how did the team actually append the false labels? Is it just how do you decide which data point to append? Yeah, this one. Yeah. So how do you decide which data point to add with the false labels?
Actually, from our exploration, we found that training data has little amount of false label, especially in off-peak hour. It might be no report on certain area for specific day and hour. Basically, it might cause difficulties for the model to learn when there are none of less data for each label. Therefore, we use that kind of imputation and sample with equal size in order to the model is able to learn more comprehensive and general pattern for both peak and off-peak hours.
I guess my question is, do you consider whether an area has many reports throughout the day versus if you look at an area whereby there's not actually that many data points to begin with? Do you add them equally, or do you add one the false labels to the one that has more reports or more data points in the first place?
Okay, I will answer the question. Thank you for your question. It's very interesting. Actually, for this imputation process, we impute the training data. We fill the gap in the training data by looking at the hour distribution. So every case that we found no data in some sectors at certain days and certain hours, we then fill or make assumption that there's no high traffic jam in that location at that specific time. So that's why we impute the data with false label. As the result, we get this distribution of new data after the imputation process. So we have a very, very large false labels on the data.
Oh, I see what you're doing. Okay.
Yeah,
all
yeah.
right.
Because as we can see that it's very imbalanced.
Right.
So
then you
yeah,
take. Okay, I see what you're doing.
We
All right.
downsample the data again, so we can have a similar label distribution, something like that.
Yep. Okay, that makes sense. All right, thanks.
Yeah, you're welcome. Any question?
Yeah. I have a question, Papa Hanif. So you're the first. You are the team with the at the first place, right? I'm wondering with your result. You told us about your result, right? The result shows that the model seems learn something between weekday and weekend, right? The counts and my question is what is your recommendation after this? You have the prediction, right? You have the prediction good enough here. Well, what is your recommendation that the city must do actually based on your prediction?
Okay, Oji, maybe you can.
Yes. Could you go to the last slide for the yeah, next one, maybe that's one. For me, the city government, when we talk about the prediction, the city can uh, create a early system that will be warning which sector that will be have a high traffic congestion, and it can be improved by the another policy. Let's say that the car or passenger transportation limitation, so that there will be not high traffic in a specific sector, I think.
And also from the descriptive perspective, I guess, from this analysis, we can get where is the areas that become the heat, that become become the hotspot for the high jump. I mean, the local government can make a clustering or classification, which sectors, which areas that have a very great opportunity to get a traffic jam, something like that. We also can focusing on some sectors like, for example, this is the result of prediction in two big cities, Bandung and Depok. As we can see in here, Bandung have a highest traffic jam in weekend, and it makes sense because Bandung is one of the top destination for people from Jakarta when they are in a weekend. So it can make the high traffic jam in Bandung at weekend. But in the other hand, if you take a look at into Depok, it seems that the high traffic jam occurred in two different times. It's in the morning and also in the evening after people go back from their work to the home. So basically, we have a lot of insight from this prediction. Either it's a descriptive or maybe prescriptive. There are a lot of data-driven solution that can be used by the government to make a data-driven policy. Thank you.
Thank you.
Okay, there's 2 minutes left. Any question from the other judges?
If no one to ask, I will ask then. I have one more question. How do you do the holdout?
Okay. For the holdout scan, right?
Yeah.
This is the configuration for our holdout scan.
Mhm.
Firstly, we set two pace for our validation. There are validation pace, and another one is testing pace. For the validation phase, we try to look up into our model solution. So we try to measure the performance. We try to looking at the best or the optimal probability threshold, and then we also want to get an optimal hyperparameter. After we got all of these things, then we try to replicate the configuration into the testing phase by using all the data sets, all the training data set that we have. So in the testing phase, we create new models by using all the training data set, and then it can be used to make a prediction for the testing data, something like that. So yeah, it's kind of like we have a two phase with different configuration for the data that is used.
Okay, but in here, as you can see in the validation part, your imputed train, the range is between 1 September to 15 November, right?
Yes.
Meanwhile, for the testing, it's 1 September to 22nd November. I mean, the range is different, right?
Yeah.
How? What do you think about it?
I think, in my opinion, we just want to try to make to mimic the real condition of the data. Let's say if we are in March 2021, let's say, so the task the government will ask us where is the traffic congestion that will happen in next week, something like that. So we just try to make the condition like we are in the end of November, in the third week, something like that.
Okay,
Then,
time's up.
Yeah, we try to measure the performance, and then we move on into the 3rd November,
yeah,
the 3rd week of November. Then we retrain the models and then make another prediction, something like that. So it's basically a weekly machine learning solution.
Yeah, thank you.
Okay, thank you for team Papa Hani for the presentation and judges for the question. I wish you all the best for the result. Good luck, guys.
Thank you.
Thank you.
Okay, now we have end of Data National Hackathon today. Thanks to all team for the great presentation and also for the judges for the great feedback. Thank you to many great sponsors that support our events such as Microsoft, S3, Data Academy, ICRA, and special thanks to Java Data Service as our main partner for this competition. Also, from community partners such as AI for Impact, Female JIC, GML, and Ladies, Deep Tech, DSW, and media partners such as Deep Tech and Local Data. The winner will be announced in the DSI Award session in Sunday 28 March on 4 until 5 p.m. But before the announcement award, on next day, we also have a webinar concert from our keynote speaker and panel discussion talk. And for the judges, Mr. Alamsyah, Mr. Akbar, Mr. Endian, and Ms. Alvina, please not leave this Zoom meeting because we'll discuss about today's presentation result. But for all 13 teams, you can leave this Zoom meeting after my closing statement. Okay, it's been a pleasure being with all of you today. See you next time, guys. Wassalamualaikum warahmatullahi wabarakatuh.